Yes. Hello dear students, very good evening to all of you. I am Ankur Sharma. I welcome you all on this YouTube channel. Just do confirm audio and video so that we can start the session. As you all know and as you all aware about this session, today we are going to discuss complete subject revision of signals and system, and we will have a discussion of all the formulas, all the properties, all the short trick from where examiner can ask the question. So this is a smart revision where we are going to cover all the concept revision, all the property revision, all the short trick revision, okay, and all the general note revision. So first you should confirm audio and video in chat box so that yes sir, audio video clear sir. Surya Prakash, welcome. Gotham, welcome. Gotham also write sir, please write every point. Okay, we'll try to write every point on board beta Gotham. Okay, just stay connected till the last so that you all guys get benefited. Chaliye bachcho. So first of all, if I talk about the basic signal, some definition, definitely we can't write each and every definitions and all, otherwise we will not able to finish in the 3 hour. Okay, chaliye. So first is, if I talk about the signal, the first topic from which the gate examiner can frame the question, and we can say that the concept which examiner can involve in other expressions or other questions like operations on signals, like time shifting, time reversal, time scaling, amplitude reversal, amplitude shifting. So these are the concepts that examiner can merge with the Fourier property, Laplace property, yes or no? So you should aware these are the basic foundation of the signals and system. If I talk about the definition, signal definition, that examiner directly can't ask the signal definition. So if we talk about just the basic environment, so everyone just try to share also the session and try to be interactive. So just write the definition of signals also if you want to write signal. Anything which gives some information about the nature and behavior of some phenomena is called a signal. Signal process that, or we can say that signal is a physical quantity that vary with time, space or any other independent variable. So if I talk about any independent variable, let me talk about, these are the operations. First of all, let me take the first of all color of pen I need to select. So here in the small tape I am selecting this yellow. Okay guys, chale. So if I talk about this is called guys, this is called independent variable, and this is called guys dependent variable. So if I talk about, if signal is depending on the one independent variable, it is called one dimensional signal. If signal is depending on two or more independent variable, then it will be known as two or multi-dimensional signal. If I talk about deterministic signal, any signal which can be represented in the form of mathematical equation is known as deterministic signal. If I talk about any signal which can't be represented in a mathematical form, then it will become a random signal, noise signal. Chaliye. So now student, if I talk about the basic signals of systems classification, then signals are classified in 4 categories, as you all know, that CA-CT signal. If I talk about next, CA-DT signals, DA-CT signal and DA-DT signal, As you know that continuous in amplitude, continuous is amplitude, so both will be in the analog category, but continuous in time, discrete in time. So from here to here, if you want to jump, then you have to perform what guys? Sampling. Tell me yes or no. If you want to jump from here to here, then you have to do quantization, And if you want to jump from CA-CT to DA-DT, you have to do sampling followed by quantization. Sampling plus quantization, both you need to perform. So I hope you know, in the discrete time signal actually we are providing sampling. Sampling is a process. In the sampling we'll just replace T with NTS. Sampling also we'll discuss in chapter wise, we'll do the revision. Okay. So again guys, come to the topic. If I talk about the time reversal, basic operation only, x of t. If you want to perform x of minus t, it means in the time reversal we have to make a signal just have a mirror image with respect to y-axis. So let me take the example. Suppose that this is my signal which is having 2 to 3, magnitude is 1. This is x of t. Then can I make x of minus t? Directly sir, it is very easy. So how can I say that like this sir? I have to make a mirror image. So it will be minus 3 and minus 2 like this. Similarly, if I talk about the time scaling, of course, this is my x of t. Suppose that this is my x of t, then x of at is nothing but signal going to be compressed or expand. It depends on the value of a only. So here we have 2 to 3, whatever the scalar factor we have to divide. Suppose that a value is greater than 1, then scaling always compress the signal. If my signal, if the a value is less than 1, that is half, it means if you will divide with half in 2, it will become 4. So like that you will get. Tell me guys, yes or no? Chali. So if I talk about the shifting, time shifting always divide it, categorize two part. First is this x of t plus t naught, and second is what guys, x of t minus t naught, t of t minus t naught. Minus t naught we have provided that t naught value is positive. So t minus t naught means it is right side shifted, RSS right sided shift. Xt plus t naught means LSS left sided shift. Tell me guys, yes or no? Similarly, if I talk about the amplitude part, you can also say that amplitude reversal means we have to make a mirror image with respect to x-axis. With respect to x-axis, we need to make a mirror image, sir. We have to make a mirror image. Amplitude scaling means, suppose that this is my x of t signal. This is my x of t signal with the help of 0, 2, and this is the magnitude 1. And if I want to make 3x of t, that is amplitude scaling. So in the amplitude shifting, amplitude scaling, amplitude reversal, whatever will happen, only will execute on the y domain, on the x, on the magnitude domain. Nothing will happen in the time domain. So time domain will remain same, 0 to 2, but the magnitude 1 will multiply with 3, so it will be 3. Amplitude shifting means you can upward or downward shift the signal. Suppose that this is my x of t, and if I want to perform 2 plus x of t, then my entire signal going to be shift in the upward direction by plus 2 magnitude. So my ultimate signal will be look like this. My ultimate signal will be look like this. So it means here is 0, here we have 2, this is shifted with 2. So this is 1, so it is 3. So this is my again amplitude shifting operations as well. Yes or no, bachcho? How spoke x? Surya Prakash saying that x of n is discrete time signal or seek. Dekho, in discrete time signal chapter number, we will discuss in chapter number 4 also in today's class only. Don't worry about the discrete time signal. If you asking how to writing the discrete time signal, then just wait. Just give me, just check your comment properly. Here also I am able to see. Just wait. Yes. Yes, you are saying something. Discrete time signal, it's not discrete time signal. X of n is a discrete time signal. Chapter number 4, discrete, right now chapter number 1 is going on. Discrete time signal x of n will discuss in chapter number 4. Okay, you know how to generate. This is my x of t signal. If I will perform here t equal to nts, then here I will get the x of n signal. In the sampling, we will just replace t with nts, and we will check the signal magnitude at ts interval of time, where ts is the sampling time, fs is 1 upon ts sampling frequency. Like that, guys. So if I talk about the important property now, the important thing, how it will affect the area. This is also important, guys. So suppose that your xt signal is area. If xt signal is having the area capital A, then can you please tell me what is the area of x of t plus t naught? Can you please tell me what is the area of this, guys? Can you please tell me what is the area of x of t minus t naught? Area of x of at. Area of x of minus ka at, come on. Area of minus ka k into x of minus ka at plus b. Just try to reply fast. Guys. Yes. Yes, guys, tell me. Tell me. Some students are, I think some students are writing here. No problem. Very good. Time shifting doesn't affect the area. Very good, beta. Very good. Good evening, sir, from Karan. Very good evening. Very good evening, bachcho. Chaliye. So, student, the area of xt plus t naught will remain same. Xt minus t naught will also remain same. X of at will affect the area. That is nothing but mod of a. X of minus t again a upon mod of a. And here what will have? Minus ka k x of minus at plus b. It means area will be what, guys? A upon mod of a. Time shifting anyway doesn't affect the area. So minus k will be here only. So this is all about the area affect the time property, time shifting, time scaling, time reversal. Chaliye, so without is it minus k or plus k? Minus k upon Gautam. Shabash. Chaliye. Time shifting does not affect. Very good, beta. Very good. Chaliye. So student, now if I talk about this expression, can you please do this fast for me? Here how many operations involved? So shifting, scaling and reversal, 3 operations are involved. So you will need to what we need to do, guys? We need to travel from right to left. First we need to perform shifting, scaling and followed by reversal. So if this is my f of t, ft minus 7 I need to perform first. So how to perform ft minus 7, guys? F of t minus 7, how to perform? Ft minus 7, how to perform? It means the signal I need to shift in the right hand side by 7 distance. So minus 1, if I will shift this signal by 7 distance, then it will be at 6 locations. So 6 location only. It will be at 1 distance, so 7. Now 1 will become at 8, so it will become 8, sir. Now the signal will be look like this, like this. And 2 will become what, guys? Because it is shifting by 7 location, 7 plus 2, 9, 7 plus 3, 10. So this is the entire signal. I just only perform shifting till now, ft minus 7. I am looking for f2t minus 7. Now if I will perform here only, scaling also 2, so I need to divide with 2 here. I am just saving my time and space also. So this is my f2t minus 7. Now I am just left with reversal. If I will finally reverse my signal, then what it will be? It will be give me f of minus 2t minus 7. So ultimately the signal location will be 6 by 2, 3. So it should be start from minus 3, like that, this and this. So it means the signal going to be start from minus 3. It will be minus 3.5. I hope this is clear. Tell me yes or no. It is minus 3.5 actually. And this will be minus 4. This will be minus 4. This will be minus 4. Similarly, this will be minus 4.5. And this finally will become minus 5. So this is all about the final expression. Whatever the magnitude will remain same, that is 1 and that is 2. So it means in a single expression, if multiple operations are involved, in this single expression, shifting, scaling, reversal, all are involved. So the natural order and the first preference that we need to give, we have to travel from right to left. First we need to perform shifting, scaling, followed by reversal. Shifting, scaling, Abhinav, shabash beta, chali. So now we are going for the next. I think you all guys agree with this, already completed with this also. Chali, I am asking this question from you. As far as shifting, scaling is concerned, if you solve this question, you guys can ensure that now you know about everything about the shifting, scaling and reversal procedure. Okay, try to attempt this question. I am giving you 1 minute time, even not 1 minute time is not required even, but still I am giving 1 minute time. Just try to attempt. Take your time and try to attempt it, guys. Tell me what is the answer of this. A. Examiner asking for the A answer. X of t also given, y of t also given. What I need to perform? Yt equal to x of minus 80 plus 20. Plus 20 means it is a left side shifting, guys. It means this signal you need to shift first of all 20 distance in the left hand side. Finally perform Reversal also asking for the scaling factor. Asking for the scaling factor, anyone? Try to attempt it fast. I'm just waiting for your response. Come on. Yes. Very few questions I have taken here. Very few, because today's session intent is what? Just the formula revision, smart revision, all the concept revision. But because of time reversal scaling, I just want to check. So I have taken this question. Bolo bhai, come on. Try to attempt this question. It is very easy question actually. Chalo, now it's my turn. Student, you have to think about this. Ki, sir, if this signal, if I will shift by 20 distance, the new location of this signal will be, sir, it will become 22 actually. It will become what, guys? 22. It will become what, guys? 20. It will become what, guys? 16. So it means the signal is shifted, and after that reversal also. So if I will perform reversal, eventually it will, the nature will be like this only, but I need to, the new location will be what? Right now 16 to 22. So even if I will shift now, this location should be 16 to 22. 16 to 22. Before a 16 to 22, if this signal is this only, x of minus t plus 20. Minus t plus 20 means signal will be look like this. This location will be 16 and this location will be 22. You just need to check the scaling factor A, by which value you need to divide 16 so that it will become 4. By which value we need to divide 16 so that it will become 4. That's it. 4 question. Correct answer is 4 only. Correct answer is 4 only. It means this A value is nothing but 4. So the expression will be x of, the expression will be finally x of minus ka 4t plus 20. X of minus ka 4t plus 20. X of minus ka 4t plus 20. Yeah. Minus ka 4t plus 20. Chali. Now student, we are going for the next now. Yeah. So student, basic signal, we will discuss about the basic elementary signals, rectangular signals and all. So if I talk about the signals which you know, which the fact you know that UT, if I talk about the graphical representation is nothing but it will carry the +1 value. When if I talk about the graphical representation, if I talk about the functional representation, 1 at t is greater than 0, t is less than 0, it is 0 only. So this is all about the UT nature, as you all know that. If I talk about the important pointers that you need to remember, so UT plus U minus T will always equal to 1, guys. And if this property is true, then we also say that we can perform shifting also. A plus minus ka T naught, plus minus ka T1. UT plus minus ka T naught. And here also I am telling plus U of minus ka T plus minus ka T naught is also equal to 1, guys. Is also equal to 1. This property also it must satisfy. Anybody tell me what is U of AT? U of AT is directly equal to UT, because in the step signal we can say that directly we can discard the time scaling operation. A unit step signal is always independent to time scaling operation. Time scaling operation. Tell me guys, yes or no? So these are the basic rules for the step signals as far as property is concerned. If I talk about the running integration of UT dt, then of course it will give you a ramp signal, that is nothing but TUT. So integration of step is nothing but ramp. Similarly, if I talk about differentiation of UT, guys, the differentiation of UT is nothing but the impulse signal, that is nothing but del T. So these are the basic signals properties that you have to remember. Similarly, if I talk about, do you remember this? U of, if I talk about U of T plus T naught. So of course, the U of T plus T naught will be look like this. I have to shift the signal by minus T naught distance. Magnitude is 1. This. If I talk about U of, T minus T naught, it means my signal going to be shifted in the right hand side and it will carry the magnitude 1 at T equal to T0. Yeah. So this is all about UT plus naught, UT minus T naught, like this. Yes. Chali, if I talk about some more basic rules and regulation for the step signal, tell me guys, can you draw this U of minus T plus 4 directly? This is also a short trick I have given. Minus T, it means signal is coming from minus infinity to whatever this value, minus infinity to plus 4. So if you want to draw this, then no need to perform shifting and reversal directly. Directly you can write, you can save your time. You will come from minus infinity to plus 4, it means minus infinity to plus 4, like this. So this is the signal which is coming from minus infinity having the value 1, and this is nothing but U of minus T plus 4. If you want to draw U of minus T minus 3, Then again the signal is coming from, because of minus t reversal, signal is coming from minus infinity, but this time it will stop at minus 3. So carry one value. So this is direct curve you guys can make. Direct curve you guys can make, yes. So if examiner will ask about this guys, u of 2t minus ka 8, can you perform directly this? Yes, we know that, yes sir, we know that key step signal is directly independent to the time scaling operation. In the unit step signal, we can directly discard the time scaling factor. So can I take common 2? So inside the bracket I am left with t minus 4, and now I am eligible to discard this 2. So the signal will be look like only t minus 4, and t minus 4 means simply right sided shifting by 4 distance. My signal going to be like this one. Yeah. So this is the only answer. This is the only answer. I hope it is clear. I hope it is clear. Similarly, if anyone will ask about this, if anyone will ask about this u of minus ka 3t minus ka 9, okay, come on, minus ka 3t plus 9, chali. So how you will draw? You will just take outside 3, because it is independent to time scaling, not time reversal, okay. So 3 outside, so inside the bracket minus t plus 3 by 9, so it will become 3 like this. So directly 3 you guys can discard, so it will be u of minus t plus 3. So signal going to be what guys? Signal going to be minus infinity to plus 3, minus infinity to plus 3. So it is coming from minus infinity to plus 3, magnitude is 1, like this, u of minus t plus 3. So I hope this part is crystal clear to you. Shall we go for next? Yes. So this is all about the step signal revision guys. Step signal revision, okay. If I talk about the next part, that is ramp signal. So as you all know about this session purpose is quick revision through all the formulas, all the important properties, all the. So in this marathon session, we are trying to cover all the basic signals property and signal concepts. So ramp signal. So if I talk about the ramp signal guys, tell me ramp, signum signals all are here one by one. So if I talk about the ramp signal, ramp signal is nothing but we can say that RT is equal to TUT. RT equal to TUT. Of course, the ramp signal is unbounded signal. In the ramp signal, we have a scope to calculate the slope. And slope is nothing but difference in y upon difference in x. As of now, this is the ramp signal. So slope is 1 only. So if I talk about this signal is the ramp or not? Just let me know. If here is 4 and here is 2, the signal is ramp or not? Of course, it is also a ramp signal, but slope is not 1. Slope is what? Difference in y upon difference in x. So here my slope value is nothing but 4 upon 2. So slope is 2. So if I want to write this equation, then x of t is equal to, I can write twice of r of t. So before the r, this will represent the slope only and only if inside in the independent variable t is remain same. If on this t, if you will apply the operation like 2t, like minus 2t, like 5t, half t, then this value does not represent the slope. Okay, is this clear bachon? Surya sir, the logo is Vijaxed. Acha, you are asking for this. Okay, no problem. So student, ठीक है, ramp signal, this is all about the ramp signal. We know that the ramp signal, if I talk about the running integration minus infinity to t ut dt, tell me guys, ramp signal integration is nothing but actually t square upon t into ut. And if I talk about the differentiation of ramp signal, we'll get about the unit step signal. So these are the basic properties, unbounded signal, ramp signal, of course. So student, if you want to represent the ramp signal RT in terms of UT, then you can write TUT if you not into U of T plus minus T naught. So this is all about the ramp signal. फटाफट से हम चलते हैं without wasting of time. So if I talk about the next signum signal, that is signum signal. Is chapter number 1, it will take more time actually because chapter number 1 is the foundation, of course. Yes, so chapter number signum signal, it means functionally or graphically if you want to represent, it will carry which value guys? It will carry plus 1 value here and it will carry minus 1 value here. So this is 1, this is your signum function of t. Similarly student, if I talk about the graphical representation, signum function of t carry will value t is greater than 0 by plus 1, t is less than 0 by minus 1. So this is nothing but the signum function of t value. This is nothing but the signum function of t value. Similarly, student, if you want to have the curve ut minus u minus t is also equal to signum function of t. This is the important relation. Ut u minus t is equal to signum of t, or you can also write that signum of t is nothing but, sir, twice of ut minus ka 1. And from this equation only, you can also arrange the left hand side, right hand side part. So ut is nothing but actually 1 plus signum function of t upon 2. So these are the basic relation in terms of signum, ut and all. If I talk about, guys, signum function of signum function of signum function of signum function of t, then it will become always equal to signum function of t. It is always equal to the signum function of t. Yes. Chaliye, of course, signal function is the bounded signal. Of course, signum function is a bounded signal because carry plus 1 and minus 1 values. Chaliye. So now, student, we are going for the next. After signum, we have the rectangular signal, triangular signal. So one by one we'll discuss. So if I talk about this rectangular, triangular parallelly, so here I am having a rectangular signal, and here I will have a triangular signal. Here I will have a triangular signal. So here rectangular signal, and here we have a triangular signal. So the standard form for the rectangular signal is what, guys? The rectangular signal, we are having the standard notation from the time duration minus tau by 2 to plus tau by 2. This is t, this is a, and this is the amplitude tau. This is time duration tau. So this is my x of t signal. If I wish to represent like this, then it will be a into rectangular of t by tau. A into rectangular of t by 2. Yeah. And of course, here a is the amplitude, tau is the overall duration, like this. Similarly, student, if I talk about the ramp function, so I can also write a into rectangular of t upon tau is also equal to a into rectangular of minus ka t upon tau. Yeah. Yeah. This is also clear, guys. A rectangular t by tau equal to a rectangular of minus t by tau. It means the rectangular function is an even signal, sir. Rectangular function is an even signal, sir. Even also you can write, guys, a rectangular of t plus minus t naught upon tau should also equal to a rectangular of minus ka t plus minus ka t naught upon tau. This is all about the rectangular signal. If I talk about the triangular signal, in the triangular signal, the time duration is here. The time duration is from minus tau by 2 to plus tau by 2. Tau by 2. Yes, guys. Yes, guys. I think audible. Voice is clear. Voice is clear. Rectangle, triangle, both are even signal and independent result. Very nice, Surya Prakash. Shabash. So here, if I talk about the time duration, bachcho, it is minus tau to plus 2, and this is the amplitude A. So it can be represented as a x of t equal to a into triangular of t upon tau. But here the overall width is not tau. Overall width is 2 tau actually. But if I talk about the area is still a tau. Here is also the area is a tau. If I talk about the area is nothing but a into tau. Similarly, if I talk about the area of this also, this area is also a tau. Why, sir? Because area is nothing but triangular half into width into height. So height is a, width is 2 tau. So a tau. Similarly, this is also even. Very nice. This is also even. It means a into triangular of t by tau should also equal to a into triangular of minus ka t plus tau. In my classes, we have seen about the basic operation between in the signal You can add triangular to rectangular, you can multiply also. Like that we have seen in the classes. Just like right now we are doing just a revision, fast revision, rectangular. Now student, we are going for the next, that is sampling and sync signal. Sampling and sync signal, yes. So if I talk about sampling and sync signal, again it will represent like that. Sampling of t will be open like this, guys, sine of t upon t. Yeah. This is my sampling signal. And if I talk about as sync of, SINC, sync of t will be open like this, sine of pi t upon pi t. So however the signal is same only, but the basic difference is like that. It means if you should know how to represent sync in terms of sampling. So if I want to represent this sync function of t is nothing but actually sampling of pi t. Yeah, this is the relation between sampling and sync. And if I talk about sampling function of t, it is nothing but actually SINC sync of t upon pi. So this box gives you important relation between sampling and sync. And if you wish to make the curve, then the curve will be look like this. The curve will be look like this. Yeah. Of course, the sampling function is a bounded signal. Of course, it is a bounded signal and it is a energy signal. It is a energy signal, yes. So in later in the Fourier transform, we'll discuss about this energy and area also. Sampling function area is pi, energy is also pi. Similarly, sync function energy is 1 and area is also 1, yes. So here student, what this will become, we'll discuss in Fourier transform also. So this is my sampling function of t. What is the difference? This is my SINC sync function of t. Here we have 0, pi, 2 pi. This is the time domain, minus pi, minus 2 pi, like this. But here, because of sync function of t, pi is already there. So it is 1, 2, 3, minus 1, minus 2, like that. Similarly, student, sinusoidal signal is very easy. If I talk about any sinusoidal waveform, then it will be A into sine of omega 0 t plus theta, where A is the amplitude, omega 0 is the frequency, and phi is the phase. So this is my sinusoidal signal, where I can vary the parameter A. It means amplitude parameter, it means A and minus A. You can vary this. You can vary frequency also. And we know that frequency is reciprocal to the fundamental time, and fundamental time is nothing but 2 pi upon omega 0 here. So if frequency omega 0 is increases, then of course the time is decreasing. Similarly, if the theta value, if the plus theta means the system is lagging, minus theta means system is, plus theta means the system is having advance. Advance means it will shift in the left hand side. If we talk about A sin omega 0 t minus theta, signal going to be shift in the right hand side. So if the signal is going to be shift in left hand side, it will be leading, plus theta. If it shift in the right hand side, minus theta means lagging. Like that you can make. If I talk about the exponential signal, again very easy, exponential signal. So e to the power minus at, e to the power minus at curve is, e to the power minus at curve, exponential decaying curve, unbounded only. If I talk about e ki power plus at curve, so e ki power plus at curve also unbounded. So right now both are unbounded, but eventually if I will make this e ki power minus at into ut, it means the exponentially decaying signal I am multiplying with ut. So now it will carry only this part, and now this signal is nothing but the bounded signal. Similarly, if I talk about this one, ki sir e ki power plus at u of minus t, it means the signal going to be like this. And both signals are now bounded only. Both signals are now bounded only. And as far as area of these both signals are concerned, as far as the area of these signals are concerned, it is nothing but 1 by A. In future, we will discuss about the energy also. Energy will be 1 by 2A. If I talk about the energy of this signal, energy of nothing but 1 by 2A, yes. Similarly, if I talk about e ki power minus ka A mode of t, e ki power minus ka A mode of t, if you will draw this, then you will get a curve like this. Yeah. And it is nothing but again a bounded signal. Bounded signal plus even signal also. It is even signal also, yes. And then, tell me what about the area? What about the area of area? 1 by A will be, area will be twice by A. Area will be twice by A of this signal, yes. Is this clear to you? Sir, irrespective even an odd signal function of team signals and Gotham, 0 crossing point only. Signum is a odd signal. Signum is a odd signal, and why signum function? Your question is what, Gotham? Gotham, your question is what? Ki how signum of infinite time Infinite time it always equal to signum of t. You want to ask this question, you are asking this question. Okay, I just prove this question for you. Prove this property for you. As I told you guys, this is a smart revision. We are writing the formulas and all. Okay, still you are looking for this. Just tell me signum function of t, how to draw this. Is it plus 1 when t is greater than 0? When t is less than 0, it is minus 1. Yes. So if I will write this signum function of t, what it will become? Here t is replaced with the entire signum function of t. It means it will carry plus 1 and signum function of t greater than 0. And here also signum function of t less than 0. So when signum function t is greater than 0, it will carry plus 1 value, sir. And when signum function of t less than 0, it will carry minus 1 value. So it means if I will draw here my signum function of t first, signum function is an odd function, by the way, okay? I hope you know this, yes. Now tell me signum function of t plus 1 value, and here is minus 1 value. So this is plus 1, this is minus 1 signum function of t. Now you should tell me one more thing, ki sir here I want to draw the next, I want to draw signum of t. Yeah, this I want to draw. It means the function says that ki wherever signum function greater than 0, the above function is greater than 0. Where the above function greater than 0? Where the above function greater than 0? For t is greater than 0, sir. For positive half. For this entire positive half, it is greater than 1. So signum function is greater than 0. Signum function is greater than 0 means positive. Signum function is positive for entire half, 0 to infinity. So 0 to infinity will carry 1 value. So 0 to carry will vary 1 value. Very simple. Similarly, tell me signum function of t less than 0. It means signum function of t negative. Signum function of t जहाँ भी negative होगा वो value किसके equal? minus 1. And here signum function of this for entire minus infinity to 0, it is negative. So for this value signal will be minus 1. And eventually this will become again, actually it is nothing but the signum function. So that is why we are writing this signum function of t. I hope it is clear now, Gautam. I hope now it is clear to you. Yes, chali. So student, I expecting some important, I expecting that you already attended my classes so that we can save the time. Okay, actually no problem. Now student, we are writing about the exponential or the impulse signal properties. Okay. So if I talk about the impulse signal, I hope you remember. As far as the impulse signal is concerned, in the impulse signal we can represent by a very small rectangular pulse. Which is having inverse width and height property. So it is minus tau by 2 to plus tau by 2, 0. So height will be 1 by 2. So inverse width and height property, guys. If this width is decreasing, height will be increasing. So like that. Like that we are having. So this is nothing but we have the del t function at t. So student, we can say that my del t function as far as the functional representation is concerned, at t equal to 0, at t is not equal to 0. T equal to 0, it will always carry what, guys? T equal to 0, it will always carry infinity. T equal to 0, not 0. This is the functional representation, but it is not that, it is necessary but not sufficient condition. If you want to represent del t, then it will practically represent by the area property. Area of impulse signal is always unity because width into height, yes, width into height. If I talk about the important properties of impulse signal important property is what, guys? Xt dot del t is nothing but x0 del t. Very important property, sir. If I talk about this property, x of t dot del of t minus ka t naught, then it will become x of t naught into del of t minus t naught. Similarly, if I talk about x of t plus t naught, it will be x of minus ka t naught into del of t plus t naught. Like this we have the properties. Similarly, guys, if I talk about this, minus infinity to infinity, x of t del t dt is nothing but x of 0 only. If I talk about minus infinity to infinity, x of t del of t minus t naught into dt is nothing but x of t naught only. Yeah. X of t naught only. Make it fast, प्यारे बच्चों, make it fast. Just do reply fast. Yeah. Do reply fast. Yes sir, clear. शाबाश बेटा, शाबाश. चलिए. Similarly, student, if I talk about del of AT, do you remember the property del of AT? Surya Prakash, 1 upon mod of A into del T. 1 upon mod of A into del T. And we have seen many times directly from the impulse in the properties, a 1 marks gate question already asked in the previous year of gate exam or even the PSU examination. So student, I hope this is clear to you. Now I am going for the next slide. So as far as impulse properties are concerned, important property, even you can write also minus infinity to infinity x of t minus t1 del of t minus t2 dt is actually equal to what, guys? X of this t2 will replace in place of t. So it will be x of t2 minus t1 only. That's it. X of t2 minus t1 only. That's it. Yes. So write it fast, all the properties, write it fast. Yes sir, very good. Remember sir. Shabash Surya Prakash beta, very good. Chali, all the properties we have revised. Now if I talk about the doublet signal. So before going to solve this, first we'll have the doublet signal important properties. Do you know the doublet signal will carry infinity or minus infinity at t equal to 0. At t is not equal to 0, it is 0. And the area property of doublet minus infinity to infinity, doublet signal will be always 0. The area of the doublet signal is always 0. Doublet signal is nothing but the differentiation of a impulse signal. The very important property ft dot del dash t is nothing but f0 is nothing but f0 del dash t minus ka f dash 0 dot del t. This is again a scaling property, very important property. And in this property only, if you will integrate both sides, so minus infinity to infinity, f of t dot del dash t dt equal to what, guys? Equal to minus infinity to infinity f0 del dash t dt minus infinity to infinity f dash 0 del t dt. So you know that the area of doublet signal is 0, so this is 0 only. So similarly, how you will get this? You will get finally minus infinity to infinity f of t dot del dash t dt should be equivalent to minus ka f dash 0, because this area of del t is 1. So this is nothing but the important property. Similarly, yeah, I can also write like this, okay, sir, if minus infinity to infinity, it will become f of t dot del dash t minus ka t naught into dt, then it will be minus ka f dash t naught, minus ka f dash t naught. Yeah, important property. And if you know this property, if you know this box ft dot del dash t, then t cube del dash t is always 0. Even we know that t ki power n del dash t will be always 0 if n is greater than 1. If n is 1, then it will become t dot del dash t, and which is always equal to minus ka del t. All these property we have derived in the classroom. If you are my classroom student, we have seen all the properties. Student, you have to remember all the boxes today. Today's session object is what? We want to revise all the complete formulas, properties, short trick in this 3R. Okay, chali. So now t del dash t is nothing but minus ka del t, sir. Chaliye next. So I am asking some questions. Cos t dot del t. What about this? Cos t function is ft. You can just apply this property. You will get the answer. Bolo yes or no? So what is the answer? Cos 0, f0 means cos 0 del dash t minus ka cos differentiation is minus sign. Bolo yes or no? Sin ka cos ka minus sign, but del of t. But what is sin 0? 0 only. So the final answer is nothing but del dash t, because cos 0 del dash t. So cos t del dash t is nothing but del dash t only, like that. Similarly, these all are the properties. These are the this is the impulse property. This is the doublet property, sir. This is the doublet property, sir. Del ki power n means minus 1 del n dxt upon t equal to t naught. Yeah. Chaliye, so it is all about the doublet signal property. Now del dash at, this is also important. Del dash at will be open like this, 1 upon a into mod of a into del dash t. This is the scaling property in the doublet signal. T del dash t is nothing but minus ka del t, that you know. And this also I have I have did the derivation in the class. I hope you remember. If you are my classroom student, you must know that I was your ex online student, sir. Surya Prakash, क्या बात है बेटा? Very good बेटा, very good Surya Prakash. I hope you know this everything already in your notes. शाबाश बेटा Surya Prakash, शाबाश. चलिए. So now student, it's time to write. This is our favorite topic, mathematical representation of signal waveform. How to write the mathematical representation? And I am sure that you can easily write the equation. This is the simplest question. First, you need to check the slope of this line. So what is the slope, guys? What is the slope? Let me change the color of pen in the large tip. I will take red. Okay. So that here. So tell me here, the slope is 2. So I must write it will be twice of r of t minus ka 0. So twice of rt. Now I am traveling here. We are enjoying here. Now we have to come downward. So again downward minus ke saath again. Whatever the slope we have added plus 2. So it will be minus 2 r of t minus ka 1. Yeah. This is all about x of t, guys. This is all about x of t. So twice of rt minus ka twice of rt minus 1. I hope this is perfectly clear to you. I hope this is perfectly clear to you. Yes or no? Chaliye, if I talk about little bit typical this signal, so x of t signal going to be start from twice of ut. So I am going to start from twice of ut. Now after that again a ramp signal. So 2 to 4, this difference is 2, this difference is 1. So 2 by 1 is 2. So slope is 2, location is 0. So r of t, we are traveling here, but first we need to compensate the last slope. So plus 2 we have added, so here minus 2, location of moment is 1. So twice of r of t minus ka 1. Now student, from here to here if you want to jump, then 3 to 1, it means it will become minus ka 3 into u of t minus ka 1. Minus ka 3 into u of t minus ka 1. The signal will going to like this. Now this signal is going like this. We have to come again downward with minus sign. What is the slope of this? 1 upon 2. So it will be half. And the location will be r of t minus ka 3. And finally we will have plus half r of t minus ka 5. Yeah. So this is all about your x of t, guys. This is all about your x of t. I hope you guys clear with this. I hope you guys clear with this. Shabash. Twice of rt minus ka, twice of rt minus. I think 2 you have taken common, Surya Prakash. Yes, chale. So this is all about the basic signals. This is all about the basic signal transformation. Chaliye. So next फटाफट से करेंगे because we have to revise all the others. So here also student tell me twice of. So I should write slope. Slope is what? Difference in y upon difference in x. So 4 upon 1. So 4 into r of t. 4 upon 1. So slope is 4. 4 of r of t. Now going like this. So minus ka 4 into r of t minus ka 1. Minus ka 4 into r of t minus ka 1. Now like that here student. So again downward. Downward means again which sign? Minus. So this distance is 4. 4 upon 2. 2. So it will be minus ka 2 into r of t minus ka 2. Like that we are going. Now student, upward direction. Upward means again plus 2. Plus 2 r of t minus ka 4. Again we are traveling this point. So it will be plus 2 upon 1. So it will be again plus 2 r of t minus ka 4. And finally we have downward. So minus ka 2 into r of t minus ka 5. So this is all about x of t. This is all about x of t, guys. This is all about x of t, yes. So I hope this is also clear to you. Fatafat se, without wasting of time, we are going for the next. Chaliye, this is again a very easy because in a ramp signal, because only containing step nature. So here is plus 2 ka step at minus 2 location, sir. So 2u of t plus 2. Now we are traveling here, we are enjoying here. Now as soon as the one location will come, there will be jump at 3. 3 magnitude jump from 2 to 5. So it will be plus 3 into u of t minus 1. Now we are traveling here. So it will be minus ka 5 into u of t minus ka 4. Yeah. So this is all about ft, guys. This is all about ft. Yes or no? Chale. Similarly student, if I talk about ft here, I should start the signal from tan of ut. Start the signal from tan of ut now, decreasing. So minus ka tan by 4 into r of t. Like this, upward direction, it means again plus ka tan by 4 r of t minus ka 4. So this is all about the equation, guys. Very easy. Chaliye. So if I talk about this question, we have to make the curve first of all. थोड़ा सा speed up मैं करूँगा. Speed maintain करना पड़ेगा. 0.5 r of t. It means slope of the signal is half and starting from RT location. So I am starting with this, I am starting with this, okay, yes. The next location of movement is 2 actually. So I will start my signal at this and this location is 2. Because slope is half, so the magnitude will achieve it is 1 only. And now here we have plus half slope, so here we have minus half, so slope compensated. Slope compensated, okay sir, minus ka half, ut minus 2 compensated. At 3 location there will be a plus 2, plus 2. Plus 2 it means like this. So right now already I am 1, I will reach at 3 because plus 2. And finally at which location it is? 3 locations sir. And finally at 4 location there will be a jump of minus 3 step, minus 3. So like this we have, like this we have. So now you should tell me guys, if this is my x of t signal, this is my x of t signal asking for the area. Do you know the area of this first signal, signal third? Because location is different, we can easily calculate the area. So area for the first is nothing but half into width into height plus. Here the area 1 into 1, so 1 only plus. Here the area 3 to 4, 1 and 3, so 3 only. 2, so answer will be 5 only guys. Answer will be 5. Yes or no? If everything is clear till now, chat box you can write clear. In the chat box you guys can write clear, yes. Chaliye, this question I am expecting from you. I am giving you a 1 minute time and let's see how many of you can do this. Let's see how many of you guys can do this, yes. Chaliye dekhte hain. Take a 1 minute time and try to solve this. If it is a classroom, in the class I am generally giving 2 minute time, but here I am giving only 1 minute time because you know that this time we have to revise all the concept in 3 hours. So just try to complete it. I am waiting for your response. Clear. Gautam also writing clear sir. Very good beta. बोले प्यारे बच्चों. चलिए, so student I am writing this. You can also compare with your answer. So first of all, twice of ut, twice of u of t, and again the slope is 2 difference, 2 to 4, here 2 to 4, 1. So I should write here plus r of t minus ka 2, and again here minus ka r of t minus ka 4, and again minus ka 4 into u of t minus ka 4. What is the challenge in this question actually? Whatever is given is all in u form. So actually you need to convert in ut, ramp function also. So this ramp function also you need to convert into ut. So it will become t minus 2 into u of t minus ka 2. Here when you will convert this, you will get t minus ka 4 into u of t minus ka 4. And finally you have minus ka 4 of u of t minus ka. So finally when you will open this, you will get twice of ut and plus you will also get t minus ka 2 into u of t minus ka 2. You will get here t, when you will open the bracket, minus ka t into u of t minus ka 4, minus minus plus. So plus ka 4 into u of t minus ka 4 and minus ka 4 into u of t minus ka 4. So this one get cancelled out guys. So actually you need to compare minus ka t not, so answer is 0 actually, B. B for Bombay. B for Bombay, you can compare with this complete equation. I hope you are getting. Anyone who got? I know generally student getting 4 only. In general student getting 4 only. I hope you now realize your mistake. I hope now you realize your mistake. Answer is not D for Delhi, answer is B for Bombay. That is why I am taking this question here. Because there is a scope of mistake. Bolo bachcho bolo. Jaldi jaldi bolo. Just tell me. Tell me guys. Now you are getting, I hope, yes. Chali. So answer is not 4 by the way. It look like 4 but answer is 0. Chali. This is also a very beautiful question. When you will calculate the slope here, 3 by 3, 1. So the signal f of t going to be start with ramp function r of t. Signal is going to like this. First we have to compensate. So what is the slope you compensate? Minus ka 1 r of t minus ka 3. I am writing this. Similarly, student, we are just shifting. We just need to reach from this to this. So it means plus 3 to 6. The u of t minus ka 3. And finally we are here. So we need to reach from here to here. Again the slope is plus 1 r of t minus ka 3. So I am writing here plus r of t minus ka 3. And eventually this one get cancelled out. So my equation is only a ramp function r of t plus 3 of u of t minus 3. It is also interesting, guys. It is also interesting. The equation is only this for this curve to this. I hope the last one is clear, sir. Clear, sir. Next, Shabash Pata Surya Prakash as well as Gautam. I hope the last question mistake you have observed already. Chali. So this is quite easy as compared to last class. Now, if I talk about the integration, as you all know, the integration of ramp is parabolic. The integration of step is ramp. The integration of impulse is step. So here we have a rectangular curve like this. So it means the curve will take the ramp signal. So if I talk about this, here, if we have this signal, then while the process of integration, the integration also short trick. The short trick of integration is what? While the process of integration, the area of step will become the magnitude of ramp. So what is the area of this? Tell me. The area, you can write 0 to 4 and 1. So it means the area of signal is nothing but the magnitude of ramp. So I will make a ramp signal which will magnitude is 4 only, and after that no common area means constant only. So this will be the integrated curve. After that it will remain constant only. Like this, you know this. Similarly, student, if I talk about the square waveform, integration is always a triangular waveform. As I already told you, whatever the area of this is the positive magnitude ramp. Because this is the negative area, so ramp is decreasing. Again positive, again negative, positive, negative, like this. So we should also note that the square waveform integration will be always a triangular waveform. Chalo. Do you want to try this? Here also many students generally doing mistake in the first attempt. That is why I am asking to you, bolo. Do you want to attempt this? If you are my classroom student, you definitely not do the mistake. But if you are a general student, normal student, if you are not my classroom student, then maybe there is a scope that you will do the mistake. Chaliye, let's see how many of you did the mistake. Tell me. What is the integration of this? Come on. What is the integration of this, guys? Come on. My classroom student, then maybe there is a scope that you will do the mistake. Chali. I think voice is clear. I am just checking my audio. Audio is clear, I think. Yes. Yes, guys, take your time and let me know. चलिए प्यारे बच्चों. So student, tell me, because the time is less, so I am solving 5 for the 20. So 20, while the process of integration, area of step will become the magnitude of ramp. I should make a ramp which will travel 20 magnitude. And after that, what is the area? Area is 5 and 5 minus 25. Minus 25 means I need to draw a ramp which will cover minus 25 magnitude. I am starting my journey from plus 20, so I will reach at minus 5. I will reach at minus 5 as soon as the 9 location will come, and after this 9 location, that there is no common area, so it will remain constant till infinity. Like this. I hope you guys got the same. I hope you guys got the same. Bolo हाँ या ना. If you got the same, then do reply. Shabash, chali. Now come on, this is again a general students are doing mistake here, but after observing the last question, I think you will not do mistake. So 2 to the 4, area will be 4. It means I need to create a ramp which will carry magnitude 4. Okay, sir, 4. After that, the area will be 5 into 1, 5. Bolo bachcho, yes or no? Already I am at 4, and if I will travel 5 more distance, definitely I will reach at 9. So my magnitude is nothing but 9 here as soon as the 3 location will come. Now 3 to 5, the magnitude is minus 4 into minus 8. So right now I am at 9 magnitude, I need to travel minus 8 distance, so I will definitely reach at plus 1, and after this 5 location, my magnitude will be remain 1, so it will be 1 only, it will be 1 only. The magnitude is 1 only, so last magnitude is 1 only. So this is just nothing but the integration. Yes or no, guys? Chale. Of course, this is again a easy question. I am just making the integration curve here. I have a space here. So tell me 5 4 ja 20. Area of the first box is 20. It means I need to make a ramp which will travel 20 magnitude. 20 minutes after that, what is the area? Again, the area is positive itself. Some student says that some student, what they are doing the mistake, they are making a downward ramp. This is wrong. Already 5 4 ja 20. Now here is 6 and 4 difference is 2, and 2 2 ja 4. So again a 4 distance, it means again a 4 plus 4 ramp you have to make. So finally you will reach at 24, and after that we have a remain constant value. After that we will remain a constant value. I hope this is clear to you guys. Shall we go for next now? Chali. So if I talk about the differentiation, we know that the differentiation of the ramp function is a step function. But while the process of differentiation, the slope of ramp will become the magnitude of step. I am again repeating my sentence. While the process of differentiation, the slope of ramp will become the magnitude of step. And the magnitude, while the process of differentiation, the magnitude of step will become the weight of impulse. Chali. So here student, again a very good question. If you want to differentiate it, means first you need to take a slope from here to here slope. Slope is 2 upon 1, 2. So 2 slope is give you twice of ut. It gives you twice of ut. So twice of ut. Now student, after that, when you will compensate this, when you will constant line, it means you will reach at 0 only. And after that you will see that there is a decrement of this step. There is a ulta step. There is a ulta step of minus 2 magnitude. Minus 2 magnitude at one location. So when you will impulse it, when you will differentiate it, it will give you an impulse of minus 2 into which location, guys? Which location? Minus 2 into del of t minus ka 1. So yeah, this is nothing but the exact differentiation curve of this x of. You can also write the equation also of this curve. If you want to write the equation is nothing but twice of r of t minus ka twice of r of t minus ka 1 here, and again that minus ka twice of u of t minus ka 1. And if you will directly differentiate this in the equation differentiation, wherever is r, it will become u, wherever is u will become del. So after this, in the equation itself, when you will differentiate, it will give you twice of u of t minus ka twice of u of t minus ka 1, that is nothing but rectangular pulse, and minus ka twice of del of t minus ka. So this is all complete. Yes, you can cross check your answer by using the equation itself. Yes or no, bachcho? So do reply. Everything is clear, Gautam. Shall we go for next? Chali. But student, finally, if I want to differentiate this also, dxt upon dt, if you wish to differentiate this also, you have to check the slope, check the magnitude of step. So here is plus 1. So plus 1 step will give you plus 1 impulse only. It will give you plus 1 impulse only, plus 1 impulse only. So this is nothing but, guys, dxt upon dt we are drawing. Now here, from here to here, we have a slope 1 to 2. What is slope, guys? This is minus 1 value. So 1 से minus 1, 2 का difference, 2 upon 1. So slope difference in y 2, difference in x 1, 2 by 1, 2. So it means minus 2. It means from 1 to 2 location. From 1 to 2 location, or magnitude will be what, guys? Minus 2. And finally here there is a constant line. So constant differentiation is 0. So we'll achieve at 0 only. That's it. So this is nothing but the differentiation. Directly differentiation signal waveform. If you wish to differentiate this trapezoidal signal differentiation, so from here to here is a ramp nature. So it will give you a step nature. So from -1 to +1, the slope is difference in y upon difference in x. So 1 upon this -1 to 1 ka difference is 2. So 1 upon 2 half. So it means it will give you a half. Again constant line means 0 only. Similarly, as soon as the 3 location will come and 5 location will come, from here 3 to 5, what is the slope of this? So 1 upon 2 again minus half. So minus half slope means you will have the signal like this, minus ka half. And finally you will reach like this, like this. So I hope this is clear to you. So this is nothing but your dyt upon dt directly. This is nothing but your dyt upon dt directly. Is this clear प्यारे बच्चों? Yes. चलिए बच्चों, if I talk about the periodic non-periodic signal, I hope you remember t equal to 2 pi by omega 0. And if any question will come, if the signal is nothing but the addition of x1t plus x2t plus x3t, then how to check the periodicity? First you need to calculate t1, t2, t3 and so on. Now we have to check the ratio of t1 upon t2, t1 upon t3, t1 upon t4 and so on. If the ratio is a rational number, then the signal is periodic and the fundamental time period is nothing but LCM of t1, t2, t3 and so on. Similarly, if I talk about the fundamental frequency omega, it will become HCF of omega 1, omega 2, omega 3 and so on. Sometime asking in the hertz also, so it will be HCF of F1, F2, F3 and so on. So many questions in 1 marks already asked in the gate from the periodic concept, that also we have written here. If I talk about energy and power signal, then energy and power condition, energy and even and sorry, first we'll talk about even and odd. We know that if I talk about the even signal condition, the even signal is nothing but symmetrical about y-axis. So if a signal which is symmetrical about y-axis is known as even. If I talk about the odd signal, it will become x of t equal to minus x of minus t, sir. Yeah. So student, if I talk about both even plus even is always even, even minus even is also even into even is also even upon even is also even. If both are odd, odd plus odd is odd minus odd is odd. But odd into odd is what, guys? Odd into odd, odd into odd, odd into odd, t ki power cube odd signal. But when you will multiply, it will become t ki power adds, t ki power 6. So odd into even, and odd upon odd is also even. But tell me, if one signal is even, one signal is odd, if you will add sum of even plus odd, I am asking, even plus odd, nano. Even plus odd is nano, means nano, yes. Similarly here, even minus odd is also nano, sir, nano, N-E-N-O. N-E-N-O. Now tell me, even dot odd, even multiply with odd. Now odd is dominating, guys, or even upon odd is also odd. So this table you should know, guys. This table you should know, yes. And I think you also know this, कि when the signal is, if the signal is nano signal, if the signal is a nano signal, then if the signal is a nano signal, then I hope you remember the x even part of t is nothing but x of t plus x of minus t upon 2. Yeah. Similarly, if I talk about if signal is nano, then we can represent odd and even part also. So x odd part of t is nothing but x of t minus ka x of minus t upon 2. So this is nothing but even part of t and odd part of t, sir. Yeah. But it will only applicable for the, if I talk about conjugate symmetric, anti-symmetric, then it will be xt equal to, if only x minus t, then it is even. And if I perform the conjugate operation here, then it will give me conjugate symmetric condition. Similarly, if xt equal to minus ka x of minus t, it is odd condition. But if you will perform here conjugate, then it will give you conjugate anti-symmetric condition. Conjugate anti-symmetric condition. Yeah. So similarly, once you are finding even part of t, you can also find x conjugate symmetric part of t by adding this x of t plus x conjugate of minus t upon 2a. Similarly, if I talk about x conjugate antisymmetric function of t, it will give me by x of t minus x conjugate of minus t upon 2a. So guys, do reply fast so that, because I am continuously speaking, so you should also reply pedally, yes sir, clear sir, so that we can go for next fast. Yes, chali. So now student, very important, energy and power signal. And why I just told you very important, because we have a many short trick here, energy signal as well as power signal, energy and power signal, energy and power signal. So do you know the energy formula, guys? Energy formula is nothing but from minus infinity to infinity mod of x of t ka whole square dt. So this is nothing but the energy formula. If I talk about the power formula is nothing but limit t tends to infinity 1 upon 2t from minus t to plus t mod of x of t ka whole square dt. Yeah. Now student, tell me the basic signals. If I talk about energy and power, for energy signal, energy is finite and power value is 0. For the power signal, power is finite. For the power signal, power is finite, energy will become infinite. You know that, guys, the basic signals are, like if I talk about the energy example, then I hope you remember e to the power minus at ut. E to the power minus at ut, I am making the next signal also, table also I am making. So e की power minus का at ut or e की power plus at u of minus t. Both the signals are having the energy is equal to 1 by 2a. I hope you remember both are having the area is equal to 1 by a. Similarly, if I talk about e की power minus का a mod of t, its energy is nothing but 1 by 2a is 1 by a, and its area is nothing but 2 by a. Area is nothing but 2 by a. So these are the again basic signals transformation. If I talk about the energy, if I talk about first energy notation, then if you have a rectangular pulse which is having the b width and a amplitude, this is my x of t, then directly its energy will be a square into b. Again a short trick, important short trick, amazing short trick for you. If the signal is having a triangular pulse from 0 to b and the amplitude is a, then its energy is nothing but what, guys? Its energy is nothing but a square by 3 into b. Width is b, a is height. If the signal is like this, guys, if the signal is having the just a sinusoidal lobe having the width b and amplitude a, then its energy will become a square by 2 into b, like this. So these are the again star mark, guys. Star mark, they all behave as a, all look like as a short trick, all work as a short trick in the competition examination. I hope you remember this also. If anybody will ask about this e की power minus at ut plus e की power minus bt ut का energy, what is the energy of the signal x of t? Come on, x of t energy. So many students who know the 1 by 2a, they will do like this, 1 by 2a plus e की power minus bt ut 1 by 2b. What they will miss? They will miss this twice upon a plus b. This is also important, guys. Why? Because ultimately you need to make it a plus b ka whole square. A square plus b square plus twice ab, like this. I hope you guys remember this. Bolo. Yes or no? Yes. Chali. So basic signals, energy, power we have calculated. Now if I talk about e की power minus at 1 by 2a, we know this. Again 1 by 2a. Yeah. This is 1 by a. This is unbounded. Unbounded signals means NENP signals. You can say that all unbounded signals are always NENP signals. All unbounded signals are always NENP signal. UT. So if I talk about power now, acha, energy calculation also. If xt, suppose that if xt signal is having the energy capital E, then minus ka k, x of minus ka at plus b is having the energy k square into E upon mod of A. Yeah. Again a very important note. Energy calculation is independent to time shifting, time reversal, even the amplitude reversal. It only depending on the time scaling or the amplitude scaling. Time scaling A and the amplitude scaling minus k. Minus k ka whole square. Why? Because in the energy formula we have a square. A square by 3 into B. Yeah. Already discussed. A square by 3 into B. Yeah. Whenever such type of question will come, I already given you a short trick. Whenever the signal is having the magnitude, whenever the signal is having the constant magnitude at infinity, constant magnitude at infinity, it means it will always make a power signal. And if you for this short trick for this, whatever the constant magnitude till infinity, you just need to pick that value as a and the power is nothing but a square by 2. That is why 2 square by 2. Yeah. Similarly, student, if I talk about a cos omega 0 t, so power is nothing but again a square by 2 here. But here we have one trap, because generally student know this. If the signal is look like this, omega 1 is not equal to omega 2. If frequencies are not same, then we can easily calculate the power is equal to a square by 2 plus b square by 2. But if the frequencies are same, then power formula will become actually this: a square by 2 plus b square by 2 plus ab cos of phi 1 minus phi 2. Yeah. So this will become the formula like this when omega 1 is equal to omega 2. However, till now in the last 31 years, whatever gate question has been asked, which only depends on frequencies are not same. If frequencies will be same, then you know that. Chaliye guys. So shall we go for next? Chaliye. Similarly, conjugate symmetric causal non-causal guys, what? Ft equal to 0 when t is less than 0, of course a causal signal. If not equal to, Ft is not equal to 0 when t is less than 0, it will become non-causal. If I talk about the properties, I hope you remember linear, non-linear properties. A system is said to be linear if it satisfies superposition as well as homogeneous property. So let me take x square t. Whenever any operation applied on a signal, that will make the system non-linear. How many of you remember these guys? Yt equal to x square t, x cube t, root of xt, mod of xt, sine of xt. This will become always non-linear, sir. Always non-linear. So here x square t is non-linear, sir. E की power xt is also non-linear, sir. But t square xt is linear, sir, because function of time can be multiple of xt. It is allowed. If I talk about this, so t xt, of course it is linear, sir. A derivative operation is always linear in general, until and unless it is x square t, so it is non-linear, but right now it is linear only. Real part of xt is nothing but guys x of t plus x of conjugate of t upon 2. And because of this conjugate star nature will make the signal non-linear. And whenever any constant term present in the system equation, will make the system non-linear. I hope you remember. If you are attended the class, you have the classroom notes, you can easily map the classroom notes also. This is again a very easy great question, guys, asking for which is not a linear system. Not a linear means constant term. So integration, derivative, linear, au plus u is representing input, y is representing output. So b means constant term is not 0. So this is for sure non-linear. Yes. If I talk about LTI system, do you know time invariant system? A system is said to be time invariant if its input and output characteristics does not change with time. It means we know that, sir, the general important formula only I am revising, function of time into x of t. So actually we are trying to revise the 70-hour subject in the 3 hour only. So we have to be fast and we are looking for the revision of the concept of or formulas. So function of time xt is always will make the system time variant. Time variant, function of time multiple with xt. So txt means time variant only, sir. Xt square means if any operation applied on the independent variable will make the system time variant. E की power xt is of course time invariant. X of if time scaling or time reversal will be always time varying, and this minus infinity to txt is always time invariant. Even if I talk about this ki minus infinity to t plus t naught into x to d to into x to d to, yes, into x to d to, so it will also make the system what, guys? It will also make the system tiv only. It will also make the system tiv only. But if I talk about this कि sir minus infinity to minus का at x to d to, so it will make the signal what, guys? tv only. It will make the signal only tv. It will make the signal only tv, yes or no? Chali. So if I talk about the causal signal, a causal system, a system is said to be causal if its output only depends on the present and past values of input, does not depends on the future values of input. It depends on future, then of course non-causal. Memoryless means only depending on the present values of input, does not even depending on the past or future. So we can also say that all memoryless systems are always causal system, but its reverse is not true. Chali. So if I talk about the memoryless, so it will be memory system because of past. It will be memory. It is memoryless. ML. It will again memoryless. Minus infinity to t, so of course memory. Integration and derivative is always memory. And x of minus t past value, so of course memory. Memory means dynamic, by the way. So if I talk about this question, minus infinity to 5 to x to d to, so because of integration in this, it will make the system tv, time variant, and because of 5t, so time variant and non-causal. So this is the beauty. I'm not taking all the gate question, all the gate we can't take in this session, but I'm just taking example. This is how you guys can solve. Stability, BIBO concept. If you want to check the stability, you just need to replace the input signal x of t as a bounded input, and if with respect to bounded input, if the system output will also behave as a bounded signal, then only the signal is stable, system is stable, otherwise it will become unstable. So it will become, because of txt, when you will apply ut here, tut will become ramp, so it is unstable. ut plus 2, so again stable. xt plus 2t, because of this 2t nature, it will become unstable, us. Minus infinity to t x to d to, u2 का integration ramp will be unstable. x2 cos2, so x2 if I will replace as a cos2 is also bounded, by the way. So if input is cos2, then cos square it will give you 1 plus cos 2 upon 2. The first term is 1, and 1 का integration with respect to t will give you t term will make the signal unstable, like this. So now continuous time LTI system, guys, will write some important properties फटाफट से without wasting of time. So convolution is very important for the gate point of view. You must remember the formula x of t h of t minus का to d to, x of to h of t minus का to, x of to h of t minus का to d to. This is nothing but my convolution formula. Very important. If I talk about the commutative property, so if x of t convolution with ht will also equal to actually ht convolution with x of t. Similarly, if I talk about the distributive property, x1t convolution with x2t plus x3t, then it is actually equal to what, guys? x1t, open the bracket only, x2t and plus x1t convolution with x3t. If I talk about the associative property, x1t convolution with x2t convolution with x3t, and will be always equal to what, guys? If you will convolve these two first, x1t convolution with x2t first bracket, and whatever the result you can convolve with x3t. Scaling property says that, guys, कि sir, if x of t convolution with h of t will become y of t, then x of at convolution with h of at is nothing but 1 upon a y of at. Yeah. Make it fast, guys. Yeah. Do it fast. Chale. So just write down till here, guys. I am just waiting for you. If you will reply, then only the session will be in session. The purpose will solve. Okay. Just complete this. Tell me, guys. Just give me a 30-second time, just drinking water. Chale, guys. Okay. So next, shall we go for next? Chaliye. So next property is what, guys? I hope you remember properties next. Shift property. What shift property says that, sir? If x of t and h of t convolution is y of t, then x of t minus tau 1 and h of t minus tau 2 is nothing but y of t minus tau 1 minus tau 2. Convolution with impulse is nothing but what, guys? X of t convolution with del t is nothing but actually x of t. Convolution with shifted impulse. X of t convolution with del of t minus ka t naught is nothing but whatever is here, it will be shift in this place. So it will be x of t minus ka t naught. Width property what says that, guys? If x1t is having the limit from t1 to t2, if x2t is having the limit from t3 to t4, then x1t convolution with x2t having the limit from t1 plus having the limit from t1 plus t3 to t1 plus t3 to t2 plus t4. Yeah. This is the width property, guys. Just make it fast. I am just waiting for you. Once you will complete, you should reply. Yes, Gautam, definitely we'll share the PDF in the group, okay? Chaliye guys. So properties, I hope you remember these relation guys. The important relation is what? A UT convolution with UT is nothing but a TUT, ramp signal. Similarly, if I talk about UT convolution with a TUT, it means convolution of step signal with respect to ramp will give you T square by 2. And this many question has been asked from this. Even you can write like this also, कि UT plus minus T1 convolution with UT plus minus T2 will give you actually T plus minus T1 plus minus T2 into U of T plus minus T1 and plus minus T2. I am just adding here width property also. Width property also I am adding here, yes. In this I am adding width property. Similarly, if I talk about TUT convolution with TUT, then it will give you actually T cube upon 3 into U of T. So like that, basic signals, you should know that basic signals transformation. Basic signal transformation, you should know this. I hope this is crystal clear to you guys. Just do reply fast. Shall we go for next or wait? So now, the next part is here. So if I talk about the basic signals transformation, e की power minus का ATUT convolution with e की power minus का BTUT is nothing but e की power minus का AT, e की power minus का BT upon B minus का A U of T. B minus का A U of T. Similarly guys, if I talk about e की power minus का ATUT convolution with U of T is nothing but 1 minus e की power minus का AT upon A into U of T. So this is nothing but e की power like this. This is nothing but like ये. E की power minus का AT convolution with UT 1 minus like this. Important formula you have to remember. Similarly, student. Chali, I have the answer some questions for you. Here TUT sir, it is RT sir, ramp. Here directly you can write R of T minus 4 minus 2 or T minus 6 sir. Here is again ramp, U and U ramp plus 3 and minus 1, so it will become R of T plus 2 sir. Yeah. Ramp and UT, it definitely parabolic nature, so T square by 2 into UT. Ramp to this, so it will become actually T minus 4 ka whole square by 2 into U of T minus ka 4. Similarly, RT dot RT convolution is nothing but actually T cube upon 6 into U of T. Similarly, here it will become T minus ka 6 ka whole cube upon 6 into U of T minus ka 6. Here what you will get, you will get 1 minus e की power minus का 3 T minus का 2 upon 3 into U of T minus का 2. Now tell me what is the answer of this question guys. Easy question, similar question. 1 minus e की power minus का 3 T will be replaced as a T plus 3 upon 3 and U of T plus 3. An examiner asking at T tends to infinity. So e की power minus infinity is 0. So answer will be 1 by 3. अरे बोलो ना भाई, yes or no? Yes or no? 0.3333. Is it clear? Because e की power minus infinity, e की power minus का 3 t, e की power minus infinity 0. 1 minus 0 upon 3, 1 by 3. Convolution of two rectangular pulse. Again important note. Convolution of two rectangular pulse. Suppose that we have this rectangular pulse 0 to t1 magnitude, a1 amplitude. So this is x1t with respect to t. Convolution with this is my x2t. So this is 2, this is 0 to 2, t2, this is a2. So the convolution is nothing but convolution of two rectangular pulse. Convolution of two rectangular pulse having different time duration is always a trapezoidal pulse. So 0 and the curve will be look like this. So 0, here we have t1, here we have t2 and here we have t1 plus t2 with respect to t. So what is the amplitude? Amplitude is nothing but a1, a2, t1. A1, A2, T1. This is nothing but the convolution of these two. So convolution of two rectangular signal having the different time duration will give you a trapezoidal signal where the condition is T2 should be greater than T1. Similarly guys, if I talk about this convolution of a two rectangular function having the same time duration. So this is x1t convolution with again a rectangular pulse 0 to t having the magnitude a2. So of course it will give you what? Again a this time it will give a triangular pulse from 0 t to t and the amplitude will be what guys here? A1, A2, t. So this is nothing but the output yt. Convolution of two rectangular signal having the different time duration is trapezoidal, but same time duration will be triangular. क्या बात है किसने लिखा है? गौतम ने लिखा है. शाबाश बेटा गौतम, शाबाश, very good, very good. चलिए, so what is the answer of this? So if you wish to solve this question, then lower limit should add -3 -1. Signal going to be start from -4. This distance -3 to t5 distance, -1 to like 6, 7 distance. So first you need to travel 5 distance, so 1, then again 7, so 3, and finally it will end at +2 and 6, so it will be end at 8. And A1, A2, T1, what is A1? A1 4, 3 are 12. 12 multiple with this 5, 12 5 are 60. So final amplitude should be 60. This will be the answer guys. This will be the answer guys. Bolo ha ya na actually. If I talk about the eigenfunction, you know that in the continuous time LTI system, exponential is a e की power j omega t are working as an eigenfunction or eigensignal. We know that for the LTI system, if a signal x of t will be working as an eigensignal if it will provide the output y equal to kx of t. It means in the output of a system, if the output of a system is just equal to the scalar multiple of input signal, so it means here this x of t is working as an eigensignal and this k will be working as an eigenvalue. Yes. Chale guys, so I just save this PDF for you, and after that I will upload a new PDF for Fourier and Laplace. Okay, we'll just have a quick revision. So I'm just saving this. What I'm doing, I'm just save it. I just want to save it. Save as PDF. Okay, local. Okay. So here I'm writing SS1 in download. Okay, so save. Okay, SS1 is already there, so we have to change the name. Just wait guys, just wait. Okay, just give, so upload now sir as part 1. Yes, part 1 I am adding, just uploading as part 1. So I will share 3 PDF. Actually I divided in this because in the software maximum 100 slide we can upload actually. So here 83 slide already completed. So next we'll discuss about Fourier and Laplace together, and in the last slide we'll discuss the discrete time domain, jet transform and the DTFT together. Okay, DTFA. Chali. Just wait for the next 1 minute. I will upload the next PDF guys. Upload the next PDF. guys? Am I audible? Audio video is clear now? Just let me know. So let's start this continuous time Fourier analysis. So Fourier series and Fourier transform we'll discuss. So first we'll discuss about CTFS. What is continuous time Fourier series, guys? Fourier series is nothing but the representation of a non-periodic sinusoidal signal into a sinusoidal periodic signal. So the representation of a non-sinusoidal periodic signal into a sinusoidal periodic signal is nothing but the Fourier series. In the Fourier series, the signal x of t should be absolutely integrable. It means it should be bounded from minus t by 2 to plus t by 2. The signal is whatever the interval minus t by 2 to plus t by 2, x of t dt should be less than infinity. Should be less than infinity. Yes or no? Signal should be deterministic over the interval. The signal should have finite number of maxima and minima over the interval of minus t by 2 to plus t by 2. A signal is also having the finite number of discontinuity over this interval, and these all are known as the condition or existence of Fourier series, which is known as Dirichlet conditions. So if I talk about the types of Fourier series, the first type is of course trigonometric Fourier series, where f of t is equal to a0 plus sigma of n equal to 1 to infinity an cos n omega 0 t plus bn sin n omega 0 t, where a0, an and bn are the Fourier series coefficient. So a0 value is nothing but 1 by t from minus t by 2 to plus t by 2. F of t I am writing here, ft, xt, whatever you can write. So I am writing here ft, so ft dt. Similarly, the an formula will become actually twice upon t from minus t by 2 to plus t by 2. This will become ft into cos of n omega 0 t dot dt. Similarly, if I talk about bn, it will gives you twice upon t from minus t by 2 to plus t by 2. It will give you ft dot sine of n omega 0 t dot dt. So this is nothing but your a0, an and bn values. a0, an and bn values. Just guys make it fast. Is this clear or not? Is this clear? Chali. So next is polar Fourier and exponential Fourier series. So we have seen, acha, just clear, my voice is loud and clear or not? Or should I increase the volume? Bolo bhai. Should I increase the volume from my side? Bolo. My voice is loud and clear. Voice is absolutely clear. Yes. So now if I talk about the polar Fourier series, if I talk about, these are the coefficients, we know that polar Fourier series is known as ft equal to d0 plus sigma of n equal to 1 to infinity dn cos n omega 0 t minus phi n, where d0 is equal to a0, where dn is equal to root of an square plus bn square, and where phi n is nothing but tan inverse of bn upon an. So these are the relation between trigonometric and polar Fourier series. If I talk about the very important exponential Fourier series, as we know that ft formula is nothing but sigma of n tends to minus infinity to infinity cn e to the power plus jn omega 0 t. This is the formula. Here sometime examiner can change the variable from n to k or c to a. Okay, so it will be ak also. Similarly, I am writing Cn is the exponential Fourier series coefficient, and the formula will be 1 by t minus t by 2 to plus t by 2, and here is f of t. F of t, it is f of t e की power minus का jn omega 0 t dt. And we know the property exponential Cn satisfy the conjugate symmetry condition. So Cn should equal to C conjugate of minus n. Similarly, C minus n should conjugate of C conjugate of n, like this. Cn equal to C conjugate of minus n, C minus n equal to C conjugate of n. Yes or no? Is this crystal clear to you or not? Is this crystal clear to you or not, guys? Just do reply fast. चलिए, So now student, relationship between trigonometric Fourier series and exponential Fourier series. I hope the relationship equal to Cn equal to half of a of n minus का jbn. Similarly, c minus n equal to half of a of n plus jb of n. If you will add these two, you will get an is nothing but sir cn plus c minus n. This is the first box. Second box, student, if you are looking for the bn value, actually what you will do c minus n minus cn, so that you will get minus minus plus plus jbn. Half will be 1 only. But when you will cross multiply j na, it will become 1 by j, and 1 by j is nothing but minus j. So if I will take minus n inside, I will get for sure j into c of n minus c of minus n, because minus has been changed inside, so that is why this change. So these are the relation. You can just note down this. Just note down this. Now, if I talk about the most important concept from that, we have seen many gate question examiner has already asked in last 31 year. That is nothing but symmetrical conditions. So if I talk about the first symmetrical condition even, if the signal ft is an even signal, then we must say that a naught is not equal to 0, a n is also not equal to 0, but bn should be 0. Why, sir? Because in the bn formula we are having f of t into sine of n omega 0 t, and sine function is odd function. Odd into even is odd, and odd integral is in the interval 0. Similarly, if the signal satisfying the odd condition average value will be always 0, an value will also 0, and bn is only not equal to 0. So you must say that if the signal is even signal, Fourier series contain cos harmonics. Bolo yes or no? Similarly, if odd signal is concerned, we can say that Fourier series contain sine harmonics. Sine harmonics, yes. The most important is what, guys? HWS. Here also HWS. As I told you in our classroom, it will create I'm just giving the short trick also for the HWS. If signal satisfy this condition xt equal to minus ka xt plus minus ka t by 2, then the signal will be HWS, and once the signal is HWS, it having the following properties. Its average value will be always 0. Its even harmonics will be always 0. So it means Fourier series contain only odd harmonics. Yeah. So it means if I talk about which criteria, sir, I hope you remember the criteria. Any signal which will referred as a HWS signal if it satisfy any one of the criteria. It means at t equal to 0, if the amplitude is plus a, then t equal to plus minus t by 2, amplitude should be minus a. At t equal to 0, if the amplitude is minus a, at t equal to plus minus t by 2, the amplitude should be plus a. As criteria, at t equal to 0, if we have a positive as, rising as, then here we should have the falling as. At t equal to 0, if we have the falling as, then plus minus t by 2, we should have a rising as. Slope, at t equal to 0, if we have a plus k slope, then plus minus t by 2, we should have a minus k slope. At t equal to 0, if we have the minus k slope, and t plus minus t by 2, we should have the plus k slope. If any of the one criteria will satisfy, then we say that the signal is HWS. And to satisfy the criteria, amplitude shifting is allowed, because amplitude shifting or addition or subtraction of DC term will only affect the A naught value, whereas the remain harmonics will be remain same. It means it will only affect what, guys? It means it will only affect what? It means it will only affect A0 value, harmonics will not change. Is this clear? चलो रिप्लाई भी करते रहेंगे ना साथ साथ में. चलो अगेन आई ओपन द वीडियो. यस, इंक्रीज लाइटली सर. अच्छा, वॉइस के लिए बोल रहे हो क्या? वॉइस के लिए बोल रहे हो, इंक्रीज लाइटली. ओके 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 ओके. सो आई जस्ट इंक्रीज हियर फ्रॉम माय साइड. just chaliye. So now student, we are going for the next. Here, do you know what is the Fourier exponential for this? What is this signal, guys? Impulse train. So ft can be written as a into sigma of n tends to minus infinity to infinity del of t minus ka nt. This is the t is the fundamental time period, where a is the amplitude of the impulse. This is the impulse train. So impulse train Fourier series coefficient will be always a upon capital T. I hope you remember a upon capital T, where a is the amplitude, of the signal, amplitude of the impulse train, and T is the fundamental time period. I hope it is clear to you. So let me take some few examples like waveforms I am drawing here. Some waveform I am drawing here with free hand. You should also draw parallelly. So if the signal waveform just like this, guys, you should tell me which harmonics present. And which Fourier series coefficients are non-zero, okay? Which Fourier series coefficients are non-zero. So this is my XT question number 1, question number 2. Okay, I am making some waveform fast for you. You can also reply fast. Like this we have the signal. That is periodic signal, okay? Similarly, we have this signal also. Yeah. So 1, 2, this is my 3, this is my 4, this is my 5th signal. Yeah. This is my 5th signal. Tell me which harmonics present in the first question. Which harmonics present? So what we will say that the signal is even signal. First of all, even plus HWS. Why even plus HWS? Because satisfy the amplitude criteria. This is 0, this is T by 2, and this is capital T. So it is even plus HWS, guys. Even plus HWS, it means Fourier series will contain odd harmonics of cos term. I hope it is clear to you. Odd harmonics of cos term, I hope it is clear to you. If I talk about this signal, this is odd signal plus HWS. Odd plus HWS, guys. Odd plus HWS. This is A and minus A. So this is T by 2 and this is T. So what we can say that here, Fourier series will contain only odd harmonics of sine term. Rest all are 0. Yes. It is satisfy edge criteria, because whatever the rising edge here, the falling equal edge here. This is what? This is not a HWS signal. It is only a odd signal. Guys. It is only odd signal. Only odd on the symmetrical about origin. Only odd means you can say that Fourier series will contain all harmonics of sine term. What about this? This is also odd. This is also odd plus HWS. Odd plus HWS. Why? Because symmetrical about origin, so odds, and HWS because of triangular slope criteria satisfy. So Fourier series will contain only odd harmonics of sine term. Only odd harmonics of sine term. I hope this is clear. Only odd harmonics of sine term. Gautam. देखो, is it satisfy amplitude criteria, beta? At t equal to 0 plus a amplitude here is minus a. Whatever the amplitude, beta, 2 value minus 2 value, whatever. So that is why it is HWS. This is edge criteria. This is slope criteria according to our rules. It does not satisfy because this is t. This is 2 by t by 2. This is t. So at t equal to 0 we have a slope beta, but at t by 2 we have an edge. And slope and edge we don't have any such criteria. That is why only I created this short trick for you and I have given to you to identify directly by observing the signal. In the next 1 second you will comment the signal is HWS or not. That is the only magic, guys. Yes or no? Now tell me, what about this? This is called as, this is of course a even signal. The fifth question, even plus hidden HWS. Hidden HWS, what is the meaning of hidden HWS? Hidden HWS means if the amplitude is A here, if I will shift this signal by A by 2 distance, just feel this. If I shift this signal by A by 2 distance in the downward side, then it will look like this. It will look like this. Bolo haan ya na. So it means the only difference is this is pure HWS. So pure HWS means average value 0. But here, whenever we have a hidden HWS, its A0 value will not equal to 0. Remaining harmonics will remain same. So is harmonics also, Fourier series will contain only, you can say that, odd harmonics of cos term. Why cos? Because of even. Why odd harmonics? Because of HWS. And why A0 is not equal to 0? Because of hidden. Because of hidden HWS. I hope it is clear now. क्या बात, नेहरू गोपाल ने एकदम सही लिखा है सर. A0 plus A coefficients. A0 and coefficient. Yes. चलो. I think now everything is crystal clear. After 5 examples I have given to you. चलो बच्चों, जरा बताओ, एक और एग्जांपल देता हूँ मैं. वन मोर वेव फॉर्म आई एम गिविंग टू यू. ये I hope the red pen is also somehow visible. So student, here we have A, here 0, this is also minus A, like this. So tell me here, this is A, this is fundamental time T, this is your T by 2, this is with respect to T. ये बोलो भाई बोलो, just do reply fast. Is it even or what? So first of all, it is a even signal, sir, and it is HWS also, guys. HWS also. Why HWS? Because here whatever the amplitude at T equal to T by 2 also amplitude is same. So signal will contain what, guys? You must say that signal will contain only odd harmonics of cos term. Odd harmonics of cos term. Only odd harmonics of cos term. Is this clear? क्या बात है गौतम, नाउ वेरी गुड, शाबाश बेटा. चलिए ये बता दो इसका आंसर क्या है. डोंट यू थिंक इट इज ए इम्पल्स ट्रेन? एन इम्पल्स ट्रेन Fourier series coefficient, we noted that A by capital T. So here A is weight of impulse is 1 and T minus का B is the fundamental time. So B multiple with the fundamental time. B is the integer, fundamental time value is 1. So 1 upon 1. So answer is 1 upon 1 means 1. Actually B into T, B into capital T. So capital T compare, so capital T value is 1. So A be 1, T be 1, so answer is C for Chennai. Chalo. So now if I talk about the basic properties, guys, linearity. If x1t having the Fourier series coefficient C1n, x2t having the Fourier series coefficient C2n, then A1 x1t plus A2 x2t Fourier series coefficient is nothing but A C1n plus A1 C1n plus A2 C2n. Yeah. Similarly, if I talk about the time reversal property, if xt has a Fourier series coefficient Cn, then x minus t will have the Fourier series coefficient C minus n. Directly remember, we need to time shifting property, guys. If x of t having the Fourier series coefficient Cn, then x of t minus t naught, time shifting always carries same sign, guys. So e की power minus का jn omega t naught. Similarly, if I talk about x of t plus t naught, because minus, so minus sign reflect, plus to plus, so it will be Cn dot e की power plus jn omega t naught. Student, scaling property, if xt having the Fourier series coefficient Cn, then x of at is also having the Fourier series coefficient same Cn, but which parameter will change? If xt has a fundamental time period capital T, then now it will be t by a. And if the frequency is omega, then frequency will be a omega, if a is greater than 0. If a is less than 0 means negative. If a is greater than 1 actually, if a is greater than 1, then only like that. If a is less than 1 matlab it will be 0.2 matlab half. So if you will divide with half, actually we will multiply with this like this. Bolo cho yes or no? Like that you will get. Like that you will get. I hope you are getting my point. So you just need to remember, even you can just remove this. Just remember this. If x of 80, whatever the a value is greater than 1 or less than 1, just need to divide what? The fundamental time period will be t by a and the frequency will be omega a. Now it doesn't matter a value is what. If a value is 1, a value is 2, then t by 2. If a value is half, then it will be t upon half. It will be omega into half, like that. Only these parameter will change. The Fourier series coefficient will remain same. Frequency shifting always carry opposite sign, guys. So if the xt is having the Fourier series coefficient Cn, then e की power jm omega 0 t x of t having the Fourier series coefficient c of n minus ka m. Similarly, e की power minus का jm omega 0 t dot x of t having the Fourier series coefficient cn plus m. Is this crystal clear to you? बोलो प्यारे बच्चों हाँ या ना? Yes or no? Yes. चलिए. So if x of t having the Fourier series coefficient c of n, then dxt upon dt, having the Fourier series coefficient jn omega 0 cn. And if I talk about d की power m, x of t upon dtm, then it will be actually jn omega 0 की power m cn. So all the important properties we are revising here, guys, all the important formulas, properties, characteristics. I hope till here everything is clear. Chali, shall we go for next or wait? Chali. So now next question. Indication property says that if x of t having the Fourier series coefficient Cn, then integration from minus infinity to t xt dt is nothing but actually Cn upon jn omega 0. Yeah. Cn upon jn omega 0. So if I talk about the Fourier transform, guys, Fourier transform is very important and very favorite topic of many of you. Examiner can ask a very beautiful question from this topic. So I am writing in terms of x, here writing in terms of f, no problem. So x omega is xt e की power minus का j omega t dt. Similarly, if I talk about inverse Fourier transform, it will become 1 by 2 pi minus infinity to infinity x of omega e की power plus j omega t d omega. So these are the general formulas of Fourier transform. And the condition for existence of Fourier transform is what? The signal x of t should be absolutely bounded or absolutely integrable. It means if the xt signal is a non-periodic, and second xt signal should be absolutely integrable. It means it is a bounded signal. It means we cannot find the Fourier transform of a unbounded signal. So that is why Laplace transform come into picture, because in the Laplace transform we can find out the frequency domain analysis for a unbounded signals also, because in the Laplace transform we have one additional value, that is sigma. चलिए प्यारे बच्चों. So I think this x omega, this xt is clear. This is x omega, this is 1 by 2 pi, like that. Clear? चलिए बच्चों. So if ft is an absolutely integrable, that I already told you, e की power minus at ut. So first signal, if you talk about e की power minus at ut का Fourier transform, e की power minus at ut, the Fourier transform will be 1 upon a plus j omega. Similarly, if I talk about e की power plus at u of minus t, then its Fourier transform will be 1 upon a minus का j omega. Yeah, guys, yeah. Is it clear? Now some properties of Fourier. It's linear property, very easy. If f1t, writing f in terms of f1t, so f1t Fourier transform is f1 omega. If small f2t having the Fourier transform of capital F2 omega, then A1 F1t, A2 F2t, having the Fourier transform A1 F1 omega, A2 F2 omega. Linear property, similar property, we know that. Scaling property says that, guys, if f of t having the Fourier transform f of omega, then f of at is nothing but 1 upon mod of a and f of omega by a. Similarly, if I talk about the time, I have a space here, so I am writing other properties also. If I talk about time shifting property, guys, time shifting property says that if f of t having the Fourier transform f of omega, then f of t minus t naught having the Fourier f omega e की power minus का j omega t. Time shifting always carries same sign. Similarly, it will be f of t plus t naught. The Fourier transform will be f omega dot e की power plus j omega t naught. I hope this is crystal clear to you. Time shifting always carries same sign. Similarly, guys, this is time shift only. If I talk about frequency shifting, so frequency shifting says that if x of t or f of t, whatever, I am taking x. So e की power plus j omega 0 t into x of t, the Fourier transform will be x of omega minus का omega naught. E की power minus का j omega 0 t x of t, the Fourier transform will be x of omega plus omega naught. ये. So time shifting carries same sign, frequency shifting carrying opposite sign. If you talk about the time reversal property, time reversal property says that, guys, if x of t having the Fourier transform x omega, then x of minus t having the Fourier transform x of minus omega. Yeah. Similarly, student, if I talk about differentiation property, next property sequence you can write, differentiation in time property. So if xt having the Fourier transform x of omega, then dxt upon dt having the Fourier transform j omega x omega. Very important. Again, integration in time property. Yeah. Says that, guys, if xt having the for xt or ft, whatever the signal value, x or x, f or f, no problem, from minus infinity to t, xt dt is nothing but x omega upon j omega plus pi x0 del omega. Yeah. Integration in time, pi x0 del omega, integration in time, differentiation in time. Similarly, guys, if I talk about differentiation in frequency property, says that if xt having the Fourier transform x omega, then tx of t having the Fourier transform j dx omega upon d omega. Yeah. J dx omega upon d omega. Like that. Convolution in time property, guys. Convolution in time property says that कि sir, convolution in time is nothing but multiplication in frequency. So x1t convolution with x2t is nothing but x1 omega multiply with x2 omega. So convolution in time is nothing but multiplication in frequency. Similarly, guys, the multiplication property, again very important property. Multiplication in time property. If x1t dot x2t, multiplication in time is nothing but 1 upon 2 pi convolution in frequency. So sequence you can write, guys. Last slide we have seen 5 properties like time reversal, linear property, time reversal, time shifting, frequency shifting, time scaling, 5 property, and remaining 5 properties here, 6, 7, 8, 9, 10. Like that you can write the sequence also parallelly with me. As I already told you, I will share the PDF in the Telegram group. If you have not joined the Telegram group, you should join the Telegram group. Link of Telegram is given in the description. Similarly, student, if I talk about area under time domain property, area under time domain, area under time domain. So if I talk about area under time domain, it is nothing but, sir, minus infinity to infinity x of t dt is equal to x omega at omega equal to 0. Yeah. So area under time domain, this is the area, xt signal area. Similarly, guys, area under frequency domain. Area under frequency domain. So what it will be? It will be, sir, small xt at t equal to 0 is nothing but 1 upon 2 pi minus infinity to infinity x omega d omega. So area under frequency domain is nothing but minus infinity to infinity x omega d omega is nothing but actually 2 pi small x 0. Yeah. Is nothing but 2 pi small x 0. I hope this is crystal clear to you guys. Yeah. Area under time domain, area under frequency domain, like this. So these are all the property we already discussed, yes. Now student, do you know in the time domain, real plus even Fourier transform will be real plus even only. Like example 1 ka Fourier transform 2 pi del omega. Do you know del function is even, 1 is also even. Like example, del t Fourier transform is 1 is also even, del t is also even. So even plus even, real plus even is always real plus even. Even imaginary plus even is also imaginary plus even only. But real plus odd will become imaginary plus odd, and imaginary plus odd will become real plus odd. Yeah. Just note down this. Note down this fast. I hope you remember this. If I talk about the basic standard signals Fourier transform, then del t Fourier transform will be 1. E की power minus at ut Fourier transform will be 1 upon a plus j omega. E की power at u minus t Fourier transform will be 1 upon a minus j omega. E की power minus का a mod of t Fourier transform will be twice a upon a square plus omega square. Fourier transform of this can't determine because it is an unbounded signal. And for the unbounded signal, Fourier transform is not possible. If I talk about the inverse Fourier transform of del omega, then it is nothing but what, guys? 1 upon 2 pi. So we can say that one Fourier transform is 2 pi del omega. Similarly, e की power j omega 0 t Fourier transform is what, guys? Fourier transform is 2 pi del of omega minus ka omega naught. Similarly, e की power minus का j omega naught t, and the Fourier transform is nothing but 2 pi del of omega plus omega naught. Yeah. Is this clear, guys? These are the some important formulas. Similarly, if I talk about cos omega 0 t, I hope you remember this, pi into bracket में del omega plus omega 0 plus del of omega minus omega 0. Sin omega 0 t Fourier transform is nothing but j pi del of omega plus omega 0 minus del of omega minus omega 0. These two are star mark critical signal, very important. Signum function of t Fourier transform is nothing but twice upon j omega, and ut Fourier transform, because I don't have space, I am writing here, ut Fourier transform is 1 upon j omega plus pi del omega. Yeah, 1 upon j omega plus pi del omega. Very important. Very, very important, guys. Yes. Chale. So rectangular signal Fourier transform, again a very, very, very important in the class. I told you many times. Directly remember the notation. Multiple time revision is required for this. Minus tau by 2 to plus tau by 2, if the amplitude is a, then its Fourier transform is with respect to t, if it is x of t, its Fourier transform is nothing but a tau sampling of omega tau by 2. So this is nothing but tau. This is nothing but the fundamental time period tau A. So A tau sampling of omega tau by 2. This is the Fourier transform of a rectangular pulse. This is the Fourier transform of a rectangular pulse. Similarly, guys, if I talk about the triangular pulse Fourier transform, it will become triangular pulse Fourier transform is nothing but y A tau sampling square omega tau by 2. Yeah. A tau sampling square omega tau by 2. A tau sampling square omega tau by 2. If I talk about the Gaussian pulse, this is very important for the gate point of view. In gate 21, gate 23, back to back 2 marks question has been asked from this. So I hope you remember e की power minus का pi t square. The Fourier transform is nothing but e की power minus का omega square upon 4 pi. And you know that omega value is 2 pi f. If you will put the value in omega, the left hand side part remains same, e की power minus का pi t square Fourier transform. E की power omega will 2 pi f, so 4 pi square f square upon 4 pi. So ultimately actually the box says that e की power minus pi t square 4 pi cat cancel. So e की power minus का pi f square. So Gaussian Fourier transform is nothing but Gaussian. This is also important. Gaussian Fourier transform is nothing but a Gaussian pulse. Gaussian Fourier transform is nothing but a Gaussian. Yes. One more important form that we need to remember, e की power minus का pi t square Fourier transform is nothing but e की power minus का omega square by 4a, omega square by 4 pi, that you know that omega square upon 4 pi. Bolo yes or no? Similarly, guys, if I talk about e की power minus का a t square, its Fourier transform will be, by using the scaling property we can manage, root pi by a e की power minus का omega square by 4a. Yeah. This is very important. If you remember this, you can solve gate 23 or gate 21 2 marks question very easily, even in 20 to 25 seconds. But the condition is you have to remember this. If you don't remember this, you have to derive in the examination hall. The derivation itself take 5 to 10 minute time. Yes, Charlie. So the most important, guys, Parseval theorem. I told you in many classes, this is the only Parseval theorem that is mentioned in the textbook, reference book. Minus infinity to infinity, it is energy formula of xt 1 upon 2 pi minus infinity to infinity mod of x omega or square d omega. Yeah. Now here mod of x omega is representing as energy spectral density. But the important property is this, guys. Some students don't know about this. This is x of t. This is the Parseval theorem PT1. xt dot ht is nothing but actually 1 upon 2 pi minus infinity to infinity x omega dot h minus omega d omega. Yeah. The second is, if I talk about minus infinity to infinity, if I will replace h with x, then it will be xt dot xt dt. It will become actually 1 upon 2 pi minus infinity to infinity x omega dot x of minus omega d omega. If I talk about the next, guys, minus infinity to infinity x of t dot h conjugate of t dot dt, then actually it will become 1 upon 2 pi minus infinity to infinity x omega dot h conjugate of omega d omega. Similarly, student, you can also write minus infinity to infinity x of t dot h conjugate of t dot dt is equal to 1 upon 2 pi minus infinity to infinity x omega x conjugate of omega d omega. Similarly, guys, if I talk about minus infinity to infinity mod of xt ka whole square dt will be actually equal to 1 upon 2 pi minus infinity to infinity mod of x omega ka whole square d omega. Yeah, guys. And this is nothing but, so this is PT1, this is PT2, this is PT3, Parseval theorem 3, this is Parseval theorem 4, and this is the Parseval theorem 5th. And that is nothing but this box, first box. That is nothing but the first box, yes. So if I will make it two box, one box for area of sampling, another box for energy of sampling. Yeah. Again, a very important note, guys. If I talk about sampling of T, this box is dedicated for area and this box is dedicated for energy. So sampling of T area is actually pi. So sampling of pi T area will be a scaling factor multiply, so pi by pi, a scaling factor divide, so pi by pi 1 only. And do you know, or sampling function of pi T is actually nothing but sinc function of T. So sinc function of T area is also 1. Sinc function of T area will be also 1. Yes or no? Similarly, student, if I talk about this next, that minus ka, if I talk about this next, even not minus, sinc of, SI and sinc of AT, SINC, sinc of AT, sinc of AT, area is 1 by A because now scaling factor is A. And minus ka K, SINC sinc of AT area. So you will get that minus K multiply, sir, and minus K by A. Yeah. So this is nothing but the area calculation. If I talk about energy, then you must say that sampling of T energy is what, guys? Sampling of T energy is pi. So if I talk about SINC, sinc of or sampling of pi T, bolo. Sampling of pi T energy is also pi by pi. Pi by pi matlab 1. Pi by pi matlab pi upon pi matlab 1 only. And it is equivalent to actually sampling of pi T is nothing but sinc function of T. So sinc function of T energy is also 1. Now tell me what is sinc function of AT. So sinc function of T energy is nothing but 1 by A, sir. So it will be minus का K, SINC sinc of AT का energy क्या हो गया? So energy is nothing but K का whole square divide by A. Divide by. Make it fast, guys. Make it fast. Complete this fast. I am just waiting for you. I am just waiting for you. Complete it fast. बोलिए बच्चों बोलिए. Just do reply fast. Shall we go for next or wait? चलिए. Just do reply fast. Shall we go for next, बेटा गौतम? यस सर. चलिए तो चलते हैं नेक्स्ट में. वॉइस इज क्लियर आई थिंक. ये इसका आंसर क्या? अरे सर इतना आसान क्वेश्चन. एनर्जी ऑफ दिस. तो आंसर इज सैम्पलिंग ऑफ 4 पाई टी विच इज इक्वलेंट टू SINC sinc of 4t or sinc of AT energy 1 by A, so 1 by 4. So answer is 0.25. Finish. This is question. Finish. Shabash. Sinc square 5t. This is also energy only. Sinc square 5t. So answer is 1 by 5. Sinc of AT ka square. So 1 by 5. So 0.2. So answer is 0.2. Yeah. That is why it is very effective. Bolo हाँ या ना? Tell me guys, yes or no? चलिए. So if I talk about the Fourier transform of a periodic signal, it is represented as a x omega equal to 2 pi sigma of n tends to minus infinity to infinity Cn del of omega minus ka n omega 0. This is the Fourier transform of a periodic signal, and where Cn is the Fourier series coefficient of a periodic signal x of t. Periodic signal x of t. And if I talk about the formula of Cn, you know that 1 by t minus t by 2, 2 plus t by 2 x of t dot e की पावर माइनस का j n ओमेगा 0 t dot dt. ये this is your. So if I talk about Fourier transform impulse train, then it is x omega equal to, Fourier transform is nothing but 2 pi, as you know, formula says that minus infinity to infinity Cn del of omega minus omega 0. And do you know Cn? Cn of a impulse train, Cn of a impulse train will be always a by capital T, that we know that. So just replace this Cn value with a by t. So your x omega will actually become 2 pi, even a by capital T also outside the bracket only, sigma of n tends to minus infinity to infinity del of omega minus omega 0. So this is the Fourier transform of a impulse train, Fourier transform of a impulse train, that actually we are using in the derivation of sampling theorem. I hope you remember if you attended my class, sampling theorem derivation. So matched filter. What is the matched filter, guys? In communication it is used, but as far as the impulse response is concerned, calculation is concerned, because we know the convolution we can write. So here h of t is nothing but actually x of minus t plus capital T. It means we are providing the shifting followed by reversal. So yt is nothing but x of t convolution with h of t, like this. Similarly, if I talk, let me take the example, asking for the filter, matched filter to this pulse. It means if this is my input, my matched filter impulse response will be s of minus t plus capital T. It means if I will provide plus t shifting first in the left hand side, so signal will become like this, and finally reverse. So it means the new signal will be look like this. So 0 to t, so this signal will be look like this, ye one. So it means which option correct, guys? C for Chennai. C for Chennai, correct sir. C for Chennai, correct sir. Similarly, if I talk about the Hilbert transform, Hilbert transform is an operation that does not provide any change in the magnitude of input signal xt. It only provides the minus 90 degree phase shift to the input signal. It means you can write the yt as a x of t dot e की power minus का j pi by 2 into t. So you can say that pi by 2 is phase difference. If I talk about the magnitude of this, the mode of this is nothing but 1. So mode of yt is actually equal to mode of xt as far as matched filter is concerned, as far as Hilbert transform is concerned. Hilbert transform is concerned. And actually if I talk about this ht value, this ht value is nothing but 1 upon pi t actually. 1 upon pi t actually. Yes or no? Yes. And before that, if I want to remind the duality theorem, that is very important in the Fourier transform, duality properties, guys. Duality theorem says that if x of t having the Fourier transform x of omega, then just omega replace with t, and here t replace with minus omega multiple with 2. So 2 pi x of minus omega. Xt replace with x omega, and xt omega replace with t, and t replace with minus omega, 2 pi x minus omega. So this is nothing but, guys, duality theorem. And how it will work, I hope you remember. If signum function of t Fourier transform is twice upon j omega, if you will apply the duality principle here, then the ultimate expression, I hope you remember, signum function of omega inverse Fourier transform is j upon pi t. So how we'll get this? By just applying this. Similarly, if I talk about e की power minus a mod of t, if I will apply in front of you, its Fourier transform is twice a upon a square plus omega square. And duality principle says that replace omega with t, so it will be 2a upon a square with t square, and its Fourier transform is nothing but what, guys? 2 pi e की power minus का a, t will be minus omega a. So ultimately twice a upon, even 2 get also cancel out. So it means it is a upon a square plus t square. Fourier transform is nothing but pi e की power minus का a into mod of omega a. So this is nothing but the Fourier transform. This is nothing but the Fourier transform. Is this clear, bachcho? Is this crystal clear? So student, xt equal to cos omega 0 t, Fourier transform is sin omega 0 t, and sin omega 0 t Hilbert transform is minus ka cos omega 0 t. You can just remember as a integration. So cos ka integration sin ka minus cos. Chale guys, so that now if I talk about this, and anyone want to reply the answer of this question? 4 sinc of 2t xt and asking for the energy of yt signal. Asking for this value integral, and this is nothing but the energy of yt signal, and we know that mode of yt is equal to mode of xt. It means the value of this integral is actually equal to minus infinity to infinity mode of xt whole square dt. It means yt ka energy xt ka energy ke equal hai. Then directly you can find energy is nothing but 4 ka whole square, and sinc of at energy 1 by a. So answer will be 16 by 2. So answer will be 8 only. Tell me guys, is this clear or not? I hope this is crystal clear. Which type of problems expected from this topic? Rohit Chaudhary. Dekho Rohit, if I talk about the Fourier transform, the most important part is 1 marks question examiner can frame from the properties of Fourier transform. 2 marks question examiner can form by using the Parseval theorems and all. Definitely a 2 marks question can come from the rectangular Fourier transform, triangular Fourier transform. Even we have seen that in the last 2 years, a 2 marks question consistently asked from the Fourier transform of a Gaussian pulse. That is also important. Fourier transform of the Gaussian pulse also we covered, and the Fourier transform of sampling signal, Fourier transform of rectangular signal. So similar many type of question, even all the PYQs I have solved in the classroom. So if you will solve the PYQs, you will get the point. Clear, sir? Okay, beta Rohit. I think you have asked something. Chale pyare bachcho. Now we discuss about the Laplace transform. What is the new in Laplace transform? In the Laplace transform we have x of s. So the formula will become minus infinity to infinity x of t dot e to the power minus st dot dt. And you know what is s here. So where s is equal to sigma plus j omega. So when you will put here, student, it will look like this: x of s minus infinity to infinity x of t e की power minus sigma plus j omega t dot dt. So if I talk about now x of s, it will give you what guys? Minus infinity to infinity x of t dot e की power minus sigma t dot e की power minus का j omega t dot dt. So don't you think the Laplace transform of xt is nothing but Fourier transform of xt e की power minus sigma t? So very important conclusion is what? That Laplace transform of x of t is actually equal to Fourier transform of xt dot e की power minus sigma t. So this is the additional factor e की power minus sigma t allow us to find the frequency domain analysis of a continuous time unbounded signal for certain values of sigma, and that sigma is known as region of convergence. Sorry. So if I talk about the ROC guys, the basic 2 standard form we should remember: e की power minus at ut, the Laplace transform is nothing but 1 upon s plus a, and the ROC is nothing but sigma is greater than minus a. Similarly, if I talk about e की power plus at u of minus t, its Laplace transform will be 1 upon minus s plus a, and will be sigma is less than a. So this is the box guys, this is the box, very important box. So this is the ut means right sided signal, and u minus t means left sided signal. राइट साइड e की पावर माइनस at ut राइट साइडेड, so ut means ROC ग्रेटर, किसके ग्रेटर, t के मल्टीपल के, लाइक दिस. u minus t it means ROC लेस देन, किसके लेस देन, t के मल्टीपल के, लाइक. If you remember these two form, entire ROC questions you can solve. You can solve, yes. We have some ROC e की power minus at ut. Of course, Laplace transform is nothing but 1 upon s plus a, and ROC is greater than, so sigma is greater than minus a. If I talk about the ut Laplace is 1 by s, sigma is greater than 0, like this. E की power minus, I already told you, e की power plus at u minus t, 1 upon minus s plus a, and sigma is minus s plus a, and here is sigma is less than a. E की power, ये देखो, ये minus minus, it means you will write the Laplace, because of u minus t it will minus s minus a value is still minus a, so I am taking minus a, and here also minus sign, so outside also minus sign, guys, and ultimately sigma is less than minus a. So if you will consider this minus sign inside, minus common, so minus minus plus, so s plus a, sigma is less than minus a. Similarly, if I talk about u minus t, Laplace is 1 upon minus s, sigma is less than 0. So these are the basic standard Laplace transform, basic ROC. This video. So this video is enough for complete revision. In terms of formulas, it is sufficient, but I am not considering questions and all, okay. As far as formula revision is concerned, as far as smart revision is concerned, through the properties, important concept, important formulas, important characteristics, important note, short trick, all we are going to cover here, okay, in one shot. Is it clear? So I planned for 3 hours, but maybe more than 3 hours required, because now for 3 hours only 15 minutes left. Chali. So we are not solving any questions and PYQs here, okay. In the gate score booster we have solved many questions, and earlier there also we have taken PYQs also, okay. Chaliye. So these are the important properties of ROC. ROC does not contain any pole. So one student also asking how to decide. So student, here the properties are. From the ROC concept, to make the system stable, ROC must contain unity circle. ROC must contain unity circle. Okay, and if I talk about the marginal case, guys, the marginal case is UT, where ROC is greater than 0. So from the ROC concept, we are commenting on the stability as well as for instability. If the ROC include the imaginary axis, then it will be stable. Otherwise, it will be unstable. Yes or no, guys? So we'll have a break also, guys. And we'll have a break also. You can break. Gautam says that, so last year you took 10 year signals along with questions. Is that fully enough? Yes, Gautam, yes. That also you can, that time I have taken questions also. Akansha, sir, एक doubt था, बता दीजिए. Yes, Akansha, पूछो बेटा, पूछो. Akansha, yes. So student, right sided signals, if ROC, for the right sided signals, ROC is right hand side to the rightmost pole. For the first properties, ROC does not contain any pole. Second property, for right sided signals, the common ROC will be always right hand side to the rightmost pole. For left sided signals, the common ROC will be left hand side to the leftmost pole. For both sided signals, the ROC will be, ROC must contain a rectangular strip in the S-plane. Must contain a rectangular strip in the S-plane. For the finite duration of signal, ROC can be entire S-plane. For causality, ROC must be always UT for causality. It means UT means right sided. Right sided means the causality, ROC must be right hand side to the rightmost pole. For stability, ROC must contain a imaginary axis. In the Z plane, it will be unity circle. In Z plane, it will be. आकांक्षा सर डिस्क्रीट टाइम पे पावर कैसे? अभी आने वाला डिस्क्रीट बेटा, अब आने वाला डिस्क्रीट आने वाला है अभी इसके बाद लाप्लास के बाद आएगा डिस्क्रीट बेटा. ओके, चलो जरा बताओ, इज देयर एनी कॉमन ROC बच्चों? u minus t means e की पावर, so RO sigma is less than minus 2. And here is sigma is greater than 3. Is there any common reason? No common reason. So in the both sided signals, the Laplace transform is only possible if there is a common ROC. So you should tell me, is there any common ROC possible here? Sigma less than minus 2, sigma greater than 3, no common ROC, so no Laplace transform. E की power 3t, when it will come in the numerator, it will become e की power minus 3t. So sigma is less than minus 3 and here sigma is greater than 2. So again no common ROC, no Laplace transform. No common ROC, so no Laplace transform. But here what is, guys? E की power 2t ut means sigma is greater than 2 and e की power 3t u minus t means sigma is less than 3. It means there must be a common ROC between, between 2 and 3, between 2 and 3 of course. So 2 is also here and 3 is also here. So the common ROC between 2 to 3, it means in between this we have a rectangular strip. So here Laplace transform is also possible and common ROC is also possible here. Similarly, guys, if I talk about the properties first, linearity property says that of course x1t plus ax1t plus bx2t, then the Laplace transform will be ax1s plus bx2s. And ROC definitely will be a intersection, common ROC. Scaling in time, if x of at, the Laplace transform is nothing but 1 upon mod of a x of omega x of s by a. Time shift always carries same sign. I hope you remember x of t minus t naught. The Laplace transform will be, x of s dot e की power minus का s t naught. So Aarti has asked about the energy, power and discrete time domain. Discrete time domain will come just after the Laplace. We have the sampling and after sampling we have discrete. And after discrete we have Z transform and DFT and DTFT and all. That's all. Is it clear, beta? Is this clear? Chali. So Gautam, what you are asking, beta, stable or unstable? As I told you, for the stability, ROC must include a imaginary axis. Imaginary axis. Is this clear or not? Are you talking about the last question? The last question is, this xt is unstable. This is unstable. Why unstable? Because its ROC does not include imaginary axis. Because j omega तो यहीं पे रह गया ना? Yes or no? Laplace transform we can find out for unstable system also in the Laplace transform. Fourier transform is not possible for the unbounded signal. Is it clear? Yes guys, so how many questions? देखो Laplace transform guys, देखो it is a 1 marks question definitely can come and even 2 marks questions can also come. Sometime if Fourier transform 2 marks questions came na, then maybe Laplace transform 1 marks. Similarly, if Fourier transform 1 mark, then Laplace transform definitely 2 marks. Okay, so it depends on from which topic examiner has frame. Is this clear, beta? So maximum 2 marks, minimum 1 marks. Yes. So here frequency shifting always carry opposite sign. So e की power plus at x of t, Fourier transform will be x of s minus का a, and e की power minus का at x of t, the Fourier transform will be x of s plus a guys. Similarly, if I talk about the multiplication in time property guys, you must say that if xt Fourier transform is x omega, then x of s, then tx of t, Laplace transform is nothing but minus का 1 dx of s upon d of s. Similarly, t की power n into x of t, the Laplace transform will be minus का 1 की power n dn x of s upon dsn. Differentiation property also, if I talk about differentiation property we are using in control system also. So if xt having the Laplace transform x of s, then dxt upon dt having the Laplace transform s x of s minus का x0. Similarly बच्चों, d2xt upon dt square having the Laplace transform s square x of s minus का x0 and minus का x dash 0. x0 means initial values. This is If I talk about the integration in time property, integration in time property, it will says that if xt having the Laplace transform x of s, then integration of minus infinity to t xt dt is nothing but x of s upon s. Yeah. Is nothing but x of s upon s. Sir, break 5 to 7 minutes. Gautam? Yes, yes. We'll take a break after this Laplace. Okay. Chaliye, so all the properties we have discussed, guys. All the properties we have discussed here. Even initial value, final value theorem also will discuss the property. Initial value theorem says that f0 equal to limit s tends to infinity as fs, because here we are having time equal to 0 plus 3. So this is known as the initial value theorem, guys. Similarly, if I talk about the final value theorem, in final value theorem f infinity, it means we are having limit time t tends to infinity is nothing but limit s tends to 0 as fs. But the final value theorem we can only apply if the pole of this term sfs must exist only in the left hand side of the s plane. It means pole should not be on the right hand side or on the imaginary axis. So if I talk about the Fourier transform of a causal periodic signal, it will become actually y of s ft if you apply the time shifting property here. So final expression I am writing f of s 1 minus e to the power minus ka s t naught. So here ys is nothing but fs upon 1 minus e ki power minus st naught, where fs is the Fourier transform of that pattern of signal which repeat itself. Let me take the example. If my signal yt is this, where we have this rectangular pulse repeated and the time period is 0, 2, 4, 6, 8, 10 and so on. So what you can say here, fundamental time period is 4, sir. So we can say that fundamental time period is 4. So here the fundamental time period is representing by t naught, so 4. So here this function, this interval, this function is actually representing as a f of t. So what is your y of s, guys? Your y of s is nothing but f of s upon, f of s means this, and what is ft? If you will write the ft equation, it is nothing but actually u of t minus ka 2. So it means it is nothing but ut 1 by s minus ka 1 by s e ki power minus ka 2s upon 1 minus e ki power minus ka s t naught. T naught value is 4 actually, 4s. So your ultimate expression will be 1 by s already outside the bracket. Inside you will get 1 minus e ki power minus ka 2s and upon 1 minus e ki power minus ka 4s. So this will be the only answer, guys. Just do reply fast. Just complete it fast. Yes. Same example we already completed. Okay. Same example we have already completed. Yes. So now, student, we are taking a break. We are taking a break of 10 minutes, and 10-minute break we are having. And after the break we will continue. Okay. So we'll have 10-minute break. After this break we'll continue the sampling theorem, important formulas, important equations, important properties, characteristics, or we can say that short trick. After that we'll discrete time energy, power, discrete time convolution, Z transform, important formulas, similarly discrete time. Okay बच्चों, चलिए. So we are having a break, and after the break we'll continue. Okay बच्चों. Hello guys, just confirm audio and video. Now after the break, we are starting the class again. Just confirm audio and video guys fast. So I just save this PDF again, okay, as part 2, save as PDF. Okay guys, so back sir, very good beta Gautam. So now student, just allow me for 1 minute, I will upload next PDF. Yes, Bacha. So guys, welcome back, and as Gautam asked, PDF I will upload after ending this session. Okay, beta. Once we will end this session here, immediately after that I will share the PDF part 1, part 2, part 3. Okay, so 1 to complete it. This is part 3, last part. Okay, once we will complete this, I will share the PDF in the group. Okay, Chali. I hope voice is clear. Just confirm. Actually, I think there is some lag. Okay. So student, if I talk about the sampling theorem says that, just confirm guys. I think now clear, yes. Okay sir, clear sir, okay. So student, if I talk about the sampling theorem, for the perfect reconstruction of a continuous time signal from its samples, the sampling theorem, the sampling frequency should be greater than or equal to twice of FM, where FM is the maximum frequency of a continuous time signal. So it means if I talk about XT signal, if I want to perform a sampling and T is replaced with NTS, then here I will get X of n. So let me take example. Suppose that my X of t signal is this cos of 2 pi FMT. 2 pi FMT. This is my XT signal. So what we are doing? We are doing in the sampling. What we are doing in the sampling? We are replacing T with NTS. So here if I will do this, I will get cos of 2 pi FM and T will be NTS. NTS. And do you know what is TS? TS is nothing but actually 1 upon Fs. So when you will put this value now, you will eventually get what guys? Cos of 2 pi Fm n into 1 upon Fs. So my new signal will be actually nothing but cos of 2 pi Fn, and this F I am writing as Fd, discrete time frequency. So discrete time frequency has the relation in Fm upon Fs. So here Fm is the frequency of a continuous time signal xt, frequency of x of t, Fd is a frequency of discrete time signal x of n, and Fs is the sampling frequency. Fs is the sampling frequencies. So Nyquist rate, what Nyquist rate says, guys? Nyquist rate says that minimum sampling rate, and that is nothing but twice Fm. So Nyquist rate is known as minimum sampling frequency for the perfect reconstruction of a continuous time signal back. So this is the minimum, and our range is greater than equal to twice omega m, greater than equal to twice. If it is greater than, then it's very good, but minimum should be equal. Yes, in chapter number 4 is very important. Sampling theorem, as well as discrete time energy, discrete time power, discrete time convolution. There is a very high chance that a 1 marks or a 2 marks question also can ask from this chapter. Okay, chale. Minimum 1 marks we can say, that maximum 2 marks. So if I talk about some operation revision, if this is x of n, guys, and this is the arrow, then how to make x of n plus 2? I have given as a short trick, amazing short trick I have given you. You just need to treat as a x of n minus whatever is here. You just need to treat as a location. Okay. So x of minus, what would I write here? Minus 2. It means earlier whatever you have, the value you just need to put, that is 1, minus 1, 0, minus 2, 2, 3 and 4. 1, minus 1, 0, minus 2, 2, 3, 4. Yeah. And here is x minus 2. It means earlier it was x of n minus 0. N minus 0, it means this location is 0 starting. But this time this location is going to be start from minus 2. So it means minus 2, minus 1. So 0 will be this only. So this is the trick. Similarly, u minus n plus 5, it means minus n means coming from minus infinity to plus 5. It means if you wish to make a curve, you will get a curve from minus infinity, it means coming like this, to plus 5. Plus 5 means 1, 2, 3, 4, 5, like this. So this is dash, 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 dash means coming. So u of minus n plus 5, like that we can come. So before that, we just make some short note for the sampling theorem, guys. So suppose that if xt is having the maximum frequency, Fm and Nyquist rate, then what is its Nyquist rate, guys? The Nyquist rate will be twice of Fm. So it means what is the Nyquist rate of this, guys? X of t plus minus ka t naught t. Same. It means Nyquist rate is independent to the shifting. What will be the Nyquist rate of dxt upon dt? Differentiation operation does not affect the frequency, so same. What is the Nyquist rate of integration of minus infinity to t xt dt? So again the Nyquist rate will be same. It means not change, as it is. It means not change, as it is. Is this clear, bachcho? Is this clear? Yes or no? Now if I talk about what is the Nyquist rate of x ki power m, x ki power m into t. X ki is power, it means x ka square, x ka cube. Whatever the power, guys, it will be multiply. So now my maximum frequency will become, earlier my maximum frequency is only Fm. Now because of power m, because this power is m, so my maximum frequency is m into Fm. So now what is my Nyquist rate? Nyquist rate is nothing but twice into maximum frequency. So twice into m into Fm. So this is again very important box, very important box. Just complete the box, guys. Parallelly, you should try to complete the boxes. Okay, chale. Similarly, student, I am going for the next. Suppose that if I am writing if x1t having the maximum frequency equal to f1, so its Nyquist rate will be definitely twice f1. And if I talk about x2t, so x2t maximum frequency is, if maximum frequency is f2, then its Nyquist rate will be twice into f2. So this is x1t, this is x2t. Then what is the Nyquist rate of x1t plus x2t? Tell me guys, x1t plus x2t Nyquist rate is what? So you must say that because of plus, the maximum frequency is nothing but whatever is maximum between maximum of f1 and f2. So the Nyquist rate will become what? The Nyquist rate will become what? Twice into maximum of f1, f2. It means for f1, f2, whatever the maximum value we will pick. So this is the first. The second is x1t multiply with x2t dot x1t dot x2t. Do you know guys, multiplication in time is nothing but convolution in frequency. Multiplication in time is nothing but convolution in frequency. And the beauty of convolution is what? We have to add the lower limit and upper limit as far as frequency is concerned. So we'll add the frequencies. So my maximum frequency will become, those who know, we can directly visualize this. The agenda of this session is what? You guys can visualize the concept. So maximum frequency will become f1 plus f2. And the Nyquist rate will become twice of f1 plus f2. Yeah. Similarly, student, I have a space here, so I will write here also. Now, if x1t convolution with x2t, then convolution in time is nothing but multiplication in frequency. And when you will multiply two signals, you will get the maximum value, whatever is minimum of these two multiplied signals. It means your maximum frequency will become minimum of f1, f2. And the Nyquist rate will also become twice of minimum of f1, f2. Twice of minimum of f1, f2. Yeah. Make it fast guys, make it fast. I am just waiting for you. Make it fast. चलिए बताइए. सर आप धोखा दिए हमको. तेजेंद्र नोट कंप्लीटेड सिग्नल्स इन प्लेलिस्ट लास्ट टॉपिक. अच्छा तेजेंद्र, एक्चुअली सिग्नल्स एंड सिस्टम लास्ट टॉपिक इज व्हाट? DTFT वाला बच्चों. एक्चुअली आई वाज वेरी बिजी इन क्लासेस एंड ऑल, सो नॉट एबल टू टेक द क्लासेस. सॉरी गाइस फॉर द सेम. ओके, आप मेरा मैराथन सेशन देख सकते हो बच्चों. मैराथन सेशन यू कैन सी लास्ट मैराथन सेशन. Yes, I am getting Tejendra. Last topic I was asking for DTFT wala part, that is important for EC student. In free classes, in enrolled students it is there, but for the free YouTube, I have covered the entire signals, but last part is left actually. I was supposed to do in month of January, but due to some hectic sessions, I am not able to do. चलिए बच्चों, जल्द do reply fast. Shall we go for next or wait बच्चों? Shall we go for next प्यारे बच्चों? Do reply fast. चलिए. So now student, if I talk about this, and here also today also the DFT FFT will discuss about the short formulas and all. Okay beta. Today also we'll discuss about the short trick and formulas and all. Okay. If you are looking for that last marathon session, you can just go through on this YouTube channel beta. That's a 10-hour marathon session. 10-hour marathon session. Okay. Even in the last, if it is possible, but in the chat box we can't paste the link actually. We can't paste the link chat box. Okay. In the chat box we can't paste the link. Okay. But if you will search that 10-hour marathon session, in that 10-hour marathon session, in the last I have taken some questions also even. Okay, because 10-hour today we are not taking any question because it is a formula revision. Okay बेटा तेजिंदर, चलिए. So चलो बताइए बच्चों, next is x1t, x2t we have already completed. Now suppose that signal is sync of 80. So sync of 80, SINC, sync of 80, SINC, sync of 80, then accuracy rate is what? This is also a very important note. Sync of 80 or a sync of t, accuracy rate is what? Sync of t, accuracy rate is what? You need to tell me. Sync of t, accuracy rate is what? Sync of t, accuracy rate is 1 hertz. 1 hertz. 1 hertz. Sync of 80 accuracy rate is 1 hertz. Tejinder, the name is signal sense system 10-hour marathon. 10-hour marathon. Okay. When you will go in the live section, after that you have to go down and down and down. Or you can directly write on YouTube also, in the YouTube search box, na, you can write signal sense system mega marathon or 10-hour marathon by Ankur Sharma sir. If you will write directly on YouTube search box, then also it will come. Okay beta. Chalo, sync of t. If sync of t accuracy rate is 1 hertz, then tell me guys, sync of 18 accuracy rate is what? How it will come, sir? Because you know that sync of t will actually open like that, bachcho, sin of pi t upon pi t. So do you know in the omega m is pi? If omega m is pi, then accuracy rate is nothing but twice of omega m. So twice of omega m is pi. Omega m is pi. And in terms of, this is in omega, in terms of hertz, then accuracy rate is 2 pi divided by 2 pi. So it will be 1 hertz. So sync of 80, accuracy rate is nothing but a hertz. If I talk about sync ki power k or 80, then power also multiply with this, you know that k into a hertz. I hope you remember guys. If I talk about sync of 80 plus SINC sync of BT, then directly we are talking about accuracy rate this time. So it will be what guys? It will be maximum of A and B hertz. Directly in accuracy rate because of plus. If I talk about sync of 80, convolution of sync of BT, then accuracy rate will be what guys? Then accuracy rate's convolution in time is nothing but multiplication. So it means minimum of AB hertz. Yeah. So if I talk about the next term guys, sync of 80, multiply of SINC sync of BT. So multiplication in these two, multiplication of these two signals is nothing but convolution in this. So it means the answer will be A plus B hertz directly. Make it fast guys, complete this fast. Chale. One more important pointer, that is what guys? One more important pointer, that number of sampled signals present at the output of filter or output of a sampled signal. Will be actually equal to NFS plus minus FM. Important get question asked in 2017 and 19 also. Similarly guys, if cutoff frequency FC of low pass filter is given to us, then accuracy rate twice FM is not only, this is necessary, but it is not sufficient. We have to check with this term also that cutoff frequency FC is nothing but Fs minus FM. So here also this fs, from this fs will give you minimum sampling rate. So you have to check with both the formula, whatever is maximum in these two, it will become actually the NICUS rate. If cutoff frequency is given, then you have to check both the formula, from here fs, from here NICUS rate. Is this clear beta? Dekho, now some students are saying that ki not taking, because if students are not in the live manner guys, definitely it will not motivate the faculty to take the session for a long hour. Yes or no बच्चों? चलिए, तो आप लोग कोशिश किया करो लाइव में रहने का, so that me and my team members all will try to take more and more YouTube live sessions for you. Otherwise ultimately there will be a no motivation. Okay, चलिए, तो बात करते हैं बच्चों नेक्स्ट में फटाफट से. नेक्स्ट जो है that is nothing but un minus 4. So if you will draw this, if you will draw this un minus 4, you will get the signal from 0 to 3. So it will be 0 1 2 3, it will be 1 1 1 1 like this. So it will be actually u of n minus ka u of n minus ka 4 with respect to n. This is just the time reversal guys, just reverse it. Time reversal plus shifting, you have to travel from right to left. So first shifting followed by reversal, again first shift minus 2 and followed by reversal. If you want to draw this, I just told you how to directly solve this by using the short trick. What is the short trick says that, suppose that here we have a origin. Now what you need to do, you need to do minus n plus 2. Okay, it means minus n means you have to just, right now you have write from left to right, because of x minus n you have to write from right to left just like this, 2 3 1 4, and just start the signal with this plus 2 value. So this is nothing but plus 2. So of course it is nothing but 0, it is nothing but 1, and nothing but minus 1. So this is the direct, you can save the time, you no need to make the graph and do the shiftings and all. Okay, you just need to do like this by saving the time. If this is your x of n guys, what is x of 2n? Yes sir, we can easily write x of 2n. It means decimation. This is called as decimation, this is called as interpolation. So when you will divide this, you will get actually 5, 4 will not there, 3 will be here and 1 will be here. So 1 by 2, 3 by 2 will not there. Similarly here guys, what? 3 and 1 will be there. So this is called decimation. And what about x of n by 2 guys? What about x of n by 2? So it will become actually guys 1, in between, in 0 will there actually, 2, 0, 3, 0, 4, 0, 5, 0, 4, 0, 3, 0, 2, 0, 1. Why we have placed 1, 1, 0? Because we have divided with 2. Because divided with 2, ultimately it will multiply with 2. Because if I will divide with half here, eventually it will multiply with 2. So 0, 2, 4, 6, 8. So in between, of course, there will be a 0. So this is called as interpolation. So now tell me, if this is x of n, what is x2n? So of course it will be, if arrow is here sir, it will become 2 and minus 1. This will not come, this will not come, this will not come. Similarly here guys, if arrow is here, so minus 3 will come, 2 will come and 6 will come. X of n by 2, so in between 0 will come, so 1 0, minus 1 0, 4 will come. This is interpolation, this is decimation, decimation. So decimation, decimation and interpolation. Clear? Chaliye. So this is all about the impulse function in discrete time domain, del n equal to 1. So sigma of n tends to minus infinity to infinity, del n value is equal to 1. And both important property, del an is equal to del of n here only. Whereas in the discrete time domain, del of at was actually 1 upon mod of a into del t. I hope you remember this. I hope you remember this. Bolo yes or no? So this is all about the un function. When n is greater than equal to 0, it will carry one value. So 0, 1, 2, 3 and so on, 1, 1, 1. If I talk about the ramp signal guys, 0 pe 0, 1 pe 1, 2 pe 2 like this. Ramp signal r of n is nothing but actually nu of n. Is nothing but actually nu of n. So reply karte raho bachcho, otherwise there is no sense to take live manner, okay? I will upload a recording lecture otherwise. You just need to, for a periodic signal guys, x of n equal to x of n plus m. So capital N is nothing but the fundamental time period in the discrete time domain. and its value will be 2 pi by omega 0 into small m. So where capital N is there, fundamental time period at any value of integer. So m is any integer here. M is any integer, and n is also a smallest integer for which your capital M is any value of integer for which you can make capital N as a smallest integer. For which you can make capital N as a smallest integer. Similarly, guys, the rules are same. N1, N2, N3, you have to put it x1 n plus x2 n. So fundamental time will be n will be LCM of N1, N2 like this. Even odd condition, just like same to the continuous time domain. Conjugate symmetric, only t replaced with n here. Same to same we have discussed. Naru Gopal sir, live who sir? Very good beta Naru Gopal, shabash, chali, very nice, very nice. So if I talk about the energy signal beta, energy power signal, again I need to take the blank slide. So if I talk about the energy, I think Aarti also asked about the energy power. So I am just writing first the formula. So energy formula E is nothing but sigma of n tends to minus infinity to infinity mod of xn ka whole square. So this is called the energy formula. Integration has been replaced with summation bachcho, and p equal to here limit n tends to minus infinity sigma of n tends to minus n2 plus n mod of x of n ka whole square. So upper limit minus lower limit plus 1, so it will be 1 upon 2n plus 1. So p equal to 1 upon 2n plus 1 minus n to n mod of x n ka whole square. So this is the power formula, this is the energy formula. Now if I talk about the basic signal energy, do you know A and UN? You can only find its energy if the A value is less than 1. Because if A value greater than 1, then it will become unbounded signal, and all unbounded signals are always NENP signal, that we know very well. So A and UN energy is nothing but 1 upon 1 minus का A square. देखो ये जो short trick है ना, that you will never find in test book, reference book. That is only for the competitive examination point of view important. Similarly, if I talk about A की power n, U of minus n, its energy will be 1 upon 1 minus का 1 upon A square A. So these are the short trick we have generated after solving many questions from the one topic. If you will solve many questions, more and more practice questions from a particular one topic, you can create your own short tricks. Chali. Similarly, guys, if I talk about power, UN signal is having the power half only. If I talk about AUN, then power is nothing but A square by 2 only. If I talk about A cos of omega 0 n plus phi power, so it is again A square by 2 only. If I talk about A e की power j omega 0 n के mod का power, because in the power formula we have a mod. So do you know A e की power j omega 0 n का power क्या? So if you will take the mod, e की power j mod is 1, so power is nothing but A square. Power is nothing but A square. So this is nothing but the energy formulas and power formulas and all. So because of Aarti asked this, so I am just taking the example. Suppose that student, I am writing this signal 3 की power n un. Can you find out its energy? Can you find out its energy? It is a NENP signal. Why? Because to make it bounded, this A value should be less than 1. A is greater than 3 is greater than 1. But similarly, if I talk about कि सर हाफ की पावर n un का एनर्जी क्या, डायरेक्ट फॉर्मूला बोलता है 1 upon 1 minus a का होल स्क्वायर, 1 upon 1 minus a स्क्वायर, a means हाफ का होल स्क्वायर 1/4, so answer will be 4/3. Similarly, student, if my question is this 2 dot 3/4 की power n un, then what is your answer? Then you don't just forget about this 2. Energy formula is having mod of xn का होल स्क्वायर, it means 2 का होल स्क्वायर 4 and 1 upon 1 minus a square, a का मतलब 1 minus 3 का होल स्क्वायर 9, again 9/4. So ultimate your answer will be 4 into जरा बोलो 4 upon बोलो sorry not 4 16 बच्चों, 4 का होल स्क्वायर 16 प्यारे बच्चों. So it will be 4 outside 16 upon 16 minus 9, so it will be 7, I think. Bolo hai na. So that is why this is your final answer. I hope it is clear to you. Not possible. Yes, yes, shabash. So like that we can find the energy and power beta. Yes. If same properties, memory less, similar properties we have seen in continuous time domain, same to same here. So yn equal to nxn, it means it is a memory system. Memory or memory less? Memory less, because nx. So it is ml. It is memory. N minus 1, so memory. N minus n, so of course memory. Don't worry about the writing. If you are not writing parallelly, because I am running fast, I will share the PDF also, beta. Okay, I will share the PDF. Okay. In Telegram group, which Telegram group link is given in description. Okay. So yn equal to n square plus n plus n. So is it causal, non-causal? Causal, non-causal, you can only decide by just multiplying, just checking the value n inside the bracket by using the independent variable actually. So it is causal. It is also causal. It is also non-causal. X n minus 1 4 and x n minus 4 means it n minus 1 it is depending on past. It look like it depends on future, but when you will observe closely, n equal to 0 पे तो 0 है और 0 into 4 is 0. So y0 equal to x0 मतलब यहाँ पे भी causal, यहाँ पे भी causal, यहाँ पे. Ultimately it is causal because past and present values are allowed. A system is said to be causal if the output of a system is only depends on the present values of input or past values of input, does not depends on future. So it is again a causal, and y root of n is also causal. I told you many times x of root of t. Root of t is non-causal because of fraction value, but root of n is always causal. And you will take the LCM x into x. So x into x always non-linear. X square, x into x. So first term is always non-linear. X square again will make non-linear. Xn square is linear. We can perform any operation on independent variable. Real part is non-linear because of conjugate. Even part is linear because no conjugate. Mode expression is of course non-linear. And whenever any constant term present in system equation, it will make the system non-linear. So I am writing in a short form n and nl. Shabash beta, shabash. Time variant invariant. You know that whenever any function of time multiple with n, it will make the system TV, time variant. It is also n is there, so it will TV. It is time invariant because n is only present here. Function of time again multiple with, so it is TV. Xn square, whenever any operation applied on the independent variable, it will make the system TV. Sigma of n, this is TIV, time invariant. It is similar to the integral minus infinity to t x to d2, I hope you remember. It is also TIV. Because this is mode operation, no problem, but n is only 1, so that is why TIV. That is why TIV, yes. Stable, unstable guys. Stable, unstable you can check by using BIBO concept. You know what is BIBO? It means you can replace x of n as a bounded input and check y of n. So yn equal to nxn. Yn equal to nx of n, nx of n. So it is 100% unstable guys, 100% unstable. Yn equal to xn plus 2, so it is also stable, sir. Xn plus n, so it is also unstable, sir. X square n, so it is stable, sir. So if I talk about the discrete time LTI system, the formula you know that yn equal to here, earlier the integration, here the summation, k equal to from minus infinity to infinity, x of k dot h of n minus k. What is the beauty in the discrete time domain? In the discrete time domain, we always give preference to the matrix convolution. This is simple, multiply with the entire row column wise and finally add diagonally. Okay, but we have to remember some standard properties and the standard result. Okay, so here if I talk about the commutative property, again the same similar property, I hope you remember. No need to write again. Commutative, distributive, associative, similar to the continuous time domain, as you know. Shifting property also guys, if x of n convolution with h of n is equal to yn, then x of n minus का k convolution h of n minus का m is nothing but both the shifting factor will reflect in the output. So minus का k minus का m. Convolution with impulse, so it will be x of n convolution with del n, so it will be actually x of n. Convolution with shifted impulse, so if I talk about x of n convolution with del of n minus ka n naught, so complete this expression will be shift here, so it will be actually x of n minus ka n naught. If I talk about the length property, guys, if I talk about the length property, then x1n is starting from n1 से लेके n2. If I talk about the x2n signal starting from n3 to n4, then the convolution of these two, x1n convolution with x2n, going to be start from n1 plus n3, n1 plus n3, and it will be end at n2 plus n4. ये n1 plus n3 से लेके n2 plus n4. In terms of length, x1 length is nothing but L1 is equal to upper limit minus lower limit plus 1. So it will be n2 minus n1 plus 1. Similarly, L2 length is what? L2 length is also n4 minus n3 plus 1. ये upper limit minus lower limit plus 1. And finally, student, if I will write in terms of this, suppose that this is my x1n signal and this is my x2n signal and this is my yn, which is actually a convolution of these two, x1n convolution with x2n, then what you can write? You can write if x1 is having the length L1, this is length L2, then this length L is nothing but actually L1 plus L2 minus 1. Yeah. That also we can write from here. L is equal to upper limit minus lower limit plus 1. So n2 plus n4 minus ka n1 plus n3 plus 1. So this L1, L2 we can also relate from this to this. It's very important, L1 plus L2 minus 1. And this length property and width property also allow us sometime to eliminate some options in the MCQ exam and MCQ questions. So the standard result, guys, UN convolution UN. Today we are not going to solve every question. This is just the formula revision. So in this session we are talking about the revision of formulas, properties and important tricks. So these are working as a short trick if you remember the formulas. UN convolution, which UN is nothing but n plus 1 u of n, guys. U of n convolution with ramp is nothing but n into n plus 1 upon 2 into u of n, guys. If I talk about this u of n convolution with a n u n is nothing but actually a की power n plus 1 minus 1 upon a minus 1. If a value greater than 1 or if a value less than 1, then also you can write 1 minus a की power n plus 1 upon 1 minus 1. This is very, very important, guys. If a की power n u of n convolution with b की power n u of n, the result will be a की power n plus 1 minus b की power n plus 1 upon a minus का b, upon a minus का b u of n. So this is your final answer. A n u n convolution with b n u n is nothing but a की power n plus 1 minus b की power n plus 1 upon a minus का b u. This is the question, guys. Make it fast. Narugopal, Rn of Rn we can find beta, but at the standard result we can find NUN and value. Okay, it can be n cube by 6 like that. Different values will get actually multiplication. You can find, okay, but as a standard result we can find this. As a formula you can find. If you want to find me, I can find also for you. Okay, like that. Why? How to find? I am just initiating this. Okay, beta. So if you talk about NUN convolution with NUN, okay. So the formula will be what, beta? Yn equal to sigma of k equal to minus infinity to infinity. It is working as xk hk. So what should I write? I should write k uk dot n minus ka k into u of n minus ka k. Is it clear? So it means this uk and un minus k when you will multiply now, it will give you the limit from 0 to n. So what is left now? So left part is k multiply with n minus ka k. Is this clear, beta? Now tell me, just open the bracket. So first when you will open the bracket, you will get the k equal to 0 to n, and here you will get kn first term, and minus you will get sigma of k equal to 0 to n, it is k square. Now infinite series formula you should remember, because the limit is in k, so n should be outside. So now here we are left with k equal to 0 to n, and here is k, and minus ये same है, sigma of k equal to 0 to n k square. So I am just writing for you guys n into, do you know the sum result, the sum of n numbers, k numbers, so it will be upper limit terms n into n plus 1 upon 2, multiply with n also, and minus n square, it means it will be n into n plus 1 plus 2n plus 1 upon 6. So this is the final answer. You can multiply also even, you can also subtract like this. I hope you are getting better. I hope beta you are getting, Narugopal. I hope Narugopal now you are getting. For you I have just derived it. For you I have just derived it. I hope you remember the general formulas. Sigma of n equal to 0, sigma of n equal to 0, capital N 1. So it will be actually n minus 0 plus 1. N minus 0 plus 1. Yes. Sigma of n equal to 0 to capital N. So it will be actually capital N into n plus 1 upon 2. Sigma of, I am writing in terms of small of n equal capital N, and here is n square. So it will be n into n plus 1 plus 2n plus 1 upon 6. Yeah. Similarly, if I talk about n equal to 0 to upper limit capital N, n cube. So it will be n into n plus 1 upon 2 ka whole square. I hope you remember these infinite series formulas. Infinite series formulas, yes, I know the formula. Very good, beta, very good, very good. I am your classroom student. Okay, beta, Narugopal, shabash. Shabash, beta, shabash, very good. Acha, batao jara, if I talk about this, so now, very good, beta, Narugopal. So here is, if I talk about the discrete time, I am just taking one example, it is a gate example only. So 1, 1 minus 1, here we have this, 1, 1 minus 1. Or even you can multiply this also. When you open the bracket, some part will cancel, some part will like this. So if you are the classroom student, then I think you know all the formulas and how to put the formulas also you know. Narugopal, are you offline students or online student? Are you attended class in offline Janagar or online? Chalo, 1, 1 minus 1, and here also we have 1, 1 minus 1. So how to do matrix convolution, linear convolution? You just need to multiply. Here is also we have arrow. This 1 multiply the entire row. So it will be 1, 1 minus 1. It will be 1, 1 minus 1. It will be minus 1 minus 1 plus 1. So ultimately what it will be, guys? Ultimately what it will be? You have to just diagonally add. Just add. So when you will add diagonally, you will get eventually 1. 1 plus 1, 2. 1 or minus 1, 0, so minus 1. Minus 1 will become minus 2. And finally will become plus 1. And here we have a origin. Why origin? Because the midpoint, if you will just extend the arrow, the midpoint will here. It means this minus 1 will give you midpoint. Examiner asking for y minus 1, so answer is 2. Y minus 1 is 2 only. Y minus 1 is 2. Online choice batch. Very good, beta. Very good, Narugopal. Very good. So I think you attended signals class also online manner. Even control also recently control I think. Control I have not taught in live online. Yes, yes. But signals I think you completed. Yes, beta. Shabash. Chale bachcho. So if I talk about the Z transform formula says that x of Z equal to sigma of n tends to minus infinity to infinity x of n dot z ki power minus. And where z is equal to what, guys? Where actually z equal to r e ki power j omega. Where actually z equal to r e ki power j omega. So when you will put this, actually you will get sigma of n tends to minus infinity to infinity x of n dot r की power minus n और e की power minus का j omega n. And in this formula, if I will put r equal to 1, if I will put r equal to 1, then this formula will become dtft formula. Then this formula will become actually dtft formula. Just similar to the Laplace transform, there is a similarity between Laplace and z. In the plane, we have the similarity between s plane and z plane. And what are the similarity, guys? In the Laplace transform, whatever the imaginary axis, so imaginary axis of s plane will get mapped into unity circle in z plane. Today my energy is also less in the class, guys, because today I am having fever. I already took medicines, okay, paracetamol, and I am taking the class. So that is why maybe some of students feel that today, sir, your energy is less, okay, but you have to maintain it, because today I am not 100% well, okay. Chalo. So now again, guys, I am repeating the sentence. The left hand side of s plane will get mapped into, inside the unity circle, and the right hand side of imaginary axis, the right side part of s plane will get mapped into outside the unity circle. So student, if I talk about the basic standard formulas of Z transform, A and UN, Z transform will be 1 upon 1 minus ka A Z inverse, and ROC mode of Z is greater than mode of A. ये very important formula, guys. Very, very important standard form. Standard form for the right-sided signals. It is equivalent to or symmetrical to e की power minus का at ut. Laplace is 1 upon s plus a, sigma greater than minus a. I hope you remember. Similarly, if I talk about the left hand side, minus a की power n, u of minus n, the z transform, the formula will be 1 upon 1 minus का a z inverse and mode of z less than mode of a. ये mode of z is less than mode of a. Yeah. So this is your right side part, guys, and this is your left side part. Right side part and left side. Chale. So relationship between S plane, Z plane, as I already told you, these are the also we told you. ROC again same. ROC does not contain any pole. For the right-sided signals in the Laplace transform, ROC was right hand side to the rightmost pole, but here it will become outside to the outermost circle. So for the right-sided signal, the common ROC will be outside to the outermost circle. For left-sided signal, the common ROC will be inside to the innermost circle. For both sided signals, ROC must contain a ring in the Z plane, whereas in the Laplace, it was rectangular strip in the S plane. Here it is rectangular strip get mapped into ring in the Z plane. For finite duration of signal, ROC is entire Z plane excluding Z equal to 0 or infinity, depends on the question. Causality, ROC must be right side, so ROC must be outside to the outermost circle. And for the stability, ROC must include unity circle. In Laplace, ROC must include what? In Laplace transform, ROC must include what? In Laplace transform, ROC must include imaginary axis, and here unity circle. Here unity circle. चलिए फटाफट चलते हैं आगे. So if I talk about the basic signals, Laplace transform. Do you know un minus 3? When you will perform this now, you will eventually get 1, 1, 1 only. Why, sir? Because un and un minus 3, so it will become 1, 1, 1. Because when you will subtract after 3 to infinity, 1 minus 1, 0 only. So this Laplace transform is what? This Laplace transform is 1 plus z inverse plus z minus 2. And ROC is entire z plane. ROC is entire z plane, but excluding what? Entire z plane, but excluding what, guys? Entire z plane, but excluding z equal to 0. Why excluding z equal to 0? Bolo. Why excluding z equal to 0? because 1 by z is there and z0 1 by 0 infinity, yes. So del n z transform is 1 and ROC is entire z plane. ROC is entire z plane. Similarly, un z transform is nothing but 1 upon 1 minus ka z inverse and mod of z is greater than 1. Yeah. If I talk about 2 by 3 un half की power un, so first of all common ROC is what? So common ROC is एक बोलता है greater than half, एक greater than 2 by 3. So ultimately greater than 2 by 3 because outside to the outermost circle. So you have to decide कि half बड़ा है या 2 by 3 बड़ा है. So 2 by 3 0.66 बड़ा है half से. So that is why ये. और इसका z transform is very easy. 1 upon 1 minus का 2 by 3 z inverse and again plus 1 upon 1 minus का this minus half inside the bracket and again z inverse. If I talk about this guys, cos omega 0 and un, its z transform will be 1 minus का z inverse cos of omega 0 upon 1 minus का 2 z inverse cos omega 0 plus z minus 2 plus z minus 2. Yeah. Similarly, sin omega 0 and un is nothing but z inverse dot sin omega 0 upon 1 minus का 2z inverse cos omega 0 plus z minus 2. So this is my sin omega 0 and un, this is my cos omega 0 and un, like this. Like this we have guys. Yes. चलिए प्यारे बच्चों, very good. Infinite हो जाएगा 1 by 0 sir. So this is all about the linear properties, just similar to the last one guys. We have seen the properties. चलिए. So next, shifting means same sign. So if x of n plus n naught, then what it will become? Here z की power minus n naught, but it will become z की power plus n naught xz. So time shifting always carries same sign, as you know. The scaling factor or multiply with exponential sequence. So a n x n is nothing but x of a z, a inverse z, or you can say that x of z by a, like this. Yeah. Similarly, if I talk about the time reversal property, if x of n is having the z transform x of z, then actually x of minus n having the z transform x of z inverse, or x of z inverse is nothing but x of 1 by z. The differentiation property says that if x of n having the z transform xz, then x of n minus x of n minus 1. x n minus 1 मतलब z inverse xz. So by common, तो 1 minus का z inverse xz. Similarly, 1 minus z inverse is multiply in this differentiation मतलब successive difference. Differentiation means successive difference in the discrete time domain. And here is accumulation or summation. So summation में 1 upon z inverse का divide और successive difference में multiply. Differentiation in frequency, x of n is having the z transform xz, then n xn having the z transform of minus z dx upon dz. Very important property. Even in the gate also it was asked in one time, 1 marks. So initial value theorem says that limit z tends to infinity xz, it is small x0 actually, where limit n tends to 0. Similarly, limit n tends to infinity, limit z tends to 1, z minus 1 into xz. But this final value theorem you can only apply, final value theorem is only applicable if the pole of z minus, if the pole of z minus 1 xz only exists inside the unity circle. It means does not exist outside the unity circle. Should only exist inside the unity circle. Similarly, बच्चों Laplace transform, inverse Z transform is a partial fraction long division method. As you know, if you attended my classroom class, you know that how we solve the questions and all. As today class, we are not solving the question, we are just revising the concept. Just wait. Can you please tell me the answer of this question if you know the formulas? Haru Gopal. बोलो बेटा. Haru Gopal, yes. sigma of n equal to 0 to infinity. Do you remember this formula? Sigma of n equal to 0 to infinity n into a ki power n. This formula is only applicable if a is less than 1. Answer is a upon 1 minus a ka whole square. Just apply this formula. So answer is half upon 1 minus half ka whole square. So answer is half upon 1 minus half is half ka whole square 1 by 4. So answer is 2. Answer is 2 beta haya na. I hope you remember this. Similarly this also n 0 se leke infinity n alpha ki power n. So how it will open? It will open like this, alpha upon 1 minus alpha ka whole square. And this value is given to us s equal to 2 alpha. So I am equating 2 alpha, alpha cancel out. So eventually when you cross multiply, you will get 1 minus alpha equal to 1 by root 2. And do you know 1 minus alpha 1 by root 2 is nothing but 0.707. So your alpha value is nothing but 0.293. Yeah. So your alpha value is nothing but 0.293. Yeah. Now if I talk about discrete time domain, always remember continuous plus aperiodic, it means example I am writing here, Fourier transform, CTFT. CTFT both are integration. So continuous plus non-periodic is same continuous plus non-periodic. So same. I am writing here same, no change. Similarly discrete plus periodic, that is DTFS. Example is DTFS. So in the DTFS that we are going to start, yes. So discrete plus periodic is same, discrete plus periodic, same. So here also same. But continuous plus periodic, do you remember CTFS? Continuous plus periodic will become discrete plus non-periodic. Example is CTFS. Change. Similarly, discrete plus aperiodic, that is DTFT. In DTFT, frequency domain is continuous plus periodic. Yeah, periodic plus continuous. Yeah. So this is very important. A 1 mark question already asked in the gate from this table. Already question has been asked. So if I talk about the DTFS formulas, quick revision of formulas. So DTFS formulas revision, guys. In the discrete time Fourier series, x of n equal to sigma of, we can write the formula as k equal to 0 to n minus ka 1, and here is ck e ki power plus ka j 2 pi by capital N into kn. And because it is a discrete time domain, same only. So here the ck value is 1 by n sigma of n equal to 0 to n minus ka 1. This time x of n inside e ki power minus ka j 2 pi n upon capital N. So this is your discrete Fourier series coefficient. And from this DTFS topic, from the last 31 year, 2 gate question asked from EC and 1 for W also recently, and all are based on this property that CK equal to CK plus N. It means suppose that if N value is 8, then actually C0 is equal to C8 is equal to C16 like this. C1 should be equal to C9 should be equal to C17 like this. C minus 1 equal to C7 is equal to C15 like this. So these, according to this property, periodicity property, the question has been asked. If I talk about the DTFT, important formulas, discrete time Fourier transform. The formula says that, guys, x e ki power j omega is nothing but sigma of n tends to minus infinity to infinity x of n e ki power minus ka j omega n. So this is the DTFT formula. And if I talk about the IDTFT formula, x of n outside, sir, 1 upon 2 pi close integral of minus pi to pi x e ki power j omega dot e ki power plus ka j omega n d omega. So this is nothing but your x of n. Just do it fast, guys. IDTFT. It is applicable for the aperiodic signals and absolutely summable signal. It means bounded signals. Linear property, as you all know, guys, time reversal means minus sign, so minus will be here. टाइम शिफ्टिंग ऑलवेज कैरी सेम साइन, माइनस तो माइनस, इफ यहाँ पे प्लस तो यहाँ पे भी प्लस. फ्रीक्वेंसी शिफ्टिंग ऑलवेज कैरी अपोजिट साइन. Even this is scaling n by k, so whatever k multiple with power j omega earlier, now j omega k. Frequency shifting e ki power plus j omega 0 n, so omega minus omega 0 here. If here it will be minus, then it will be plus here, opposite sign. Frequency shifting carry opposite sign. Differentiation property is same in just like the continuous time domain. If you remember, txt Fourier transform is nothing but j dx omega upon d omega. This is all about CTFT. दिस इज ऑल अबाउट DTFT. ये DTFT है और ये क्या था, ये CTFT था. ये डिफरेंशिएशन. Convolution in time is nothing but multiplication in figure that you know very well. And Parseval theorem, of course. Parseval theorem is very important. Parseval theorem n tends to minus infinity to infinity mod of xn का whole square is actually equivalent to 1 upon 2 pi again minus pi से लेके pi x e की पावर j omega का होल स्क्वायर डी. बट हाउ मेनी ऑफ यू रिमेंबर द स्टैंडर्ड Parseval form? 5 PT Parseval theorem form we have discussed in continuous time domain. Similarly, just similar to the just replica in the discrete time domain. So I am writing one more for you. You can relate the next. Minus infinity to infinity x of n dot h of n is actually equal to 1 upon 2 pi minus pi से लेके pi x e की पावर j ओमेगा डॉट h e की पावर माइनस का j ओमेगा d ओमेगा. ये गाइस ये देख रहे हो. एंड बेस्ड ऑन दिस इज ऑल्सो द Parseval theorem form. Based on this Parseval theorem, gate question also has been asked. So if you talk about h omega is 1, so do you know the result? The standard result says that sin omega cn upon pi n, the Fourier transform is nothing but a digital low pass filter omega c to pi is 0. So here is minus pi to minus omega c, and here is omega c and pi. So from minus omega c to plus omega c t 1, and from here to here 0 0 0. So omega c. So remember guys, sin omega cn upon pi n Fourier transform is nothing but this, and that is called a digital low pass filter. Okay. So if this is h of n now, then it will be actually h e की power j omega n. ये h e की power j omega. If you want to make a symmetrical image from CTFT DTFT, then sin of AT upon pi t. Sin of AT upon pi t, this will give you analog low pass filter from minus a to plus a, magnitude is 1. But sin of omega cn upon pi n, it will give you digital low pass filter from minus c to plus, from minus omega c to plus omega c, and the magnitude is 1. This is the energy of sin omega cn upon pi n. Directly remember, energy is always omega c upon pi. So this is again an important note. You have to star mark it. Sin omega cn upon pi n is nothing but omega c upon pi. Is nothing but omega c upon pi. Yes. Similarly, if I talk about this guys, you know that sin omega cn upon pi will give you low pass filter, and sampling function is always non-causal. So answer is non-causal and low pass filter. Why non-causal? Because it is also available at n is less than 0. That is why. Chalo. Do you know this property? Y x e की power j omega x y x e की power j omega y e की power minus j omega should be equivalent to sigma of n equal to minus infinity to infinity x of n dot h of n. This is a gate question. I am taking this. Why I am taking? To show you, because sometime if you will not remember this PT form, then you can't solve this. So you should write here 2 की power n minus 1 into u of minus n plus 2 multiple with 2 की power minus n plus 2 u of n plus 1. When you will check this, minus n plus 2 means limit coming from minus infinity to plus 2, and this limit goes to minus 1 to infinity. So when you will multiply the common limit, you will get the common limit from minus 1 to plus 2, and here 2 की power n, 2 की power minus 1. So don't you think 2 की power n and 2 की power minus 1 get cancelled? And here 2 की power minus 1, 2 की power plus 2, so ultimately 2 की power 1 only. So ultimately 2 outside, and inside the bracket we are left with n equal to minus 1 plus 2 and 1 here. So what is the solution of this? Upper limit minus lower limit plus 1. So twice into upper limit minus lower limit minus 1 plus 1. So 2 plus 1, 3 plus 1, 4, 2 ja 8 guys. So answer will be 8. So for this question, correct answer is 8. Make it fast. Make it fast. So now the last topic guys, DFT, discrete Fourier transform. So if I talk about the discrete Fourier, I am just taking a blank space. Discrete Fourier transform guys, DFT. In the DFT guys, the formula will be xk equal to sigma of, all the formulas you need to remember, x of n e की power minus का j 2 pi. Here the limit goes to n equal to 0 to n minus 1, n equal to 0 to n minus 1, e की power minus का j 2 pi n upon capital N into kn. So this is your DFT. Similarly, student, if I talk about IDFT, xn is outside, 1 upon capital N inside, sigma of k equal to 0 to n minus 1. Here we are having x of k dot e की power plus j 2 pi upon capital N into kn. So this is your x of n, where omega n is total factor actually. So Wn is nothing but e की power j 2 pi by n. E की power j 2 pi by n. This is nothing but total factor guys. Even e की power minus का j 2 pi by n. This is nothing but total factor. So I can rewrite this formula of DFT as a sigma of n equal to 0 to n minus 1 x of n and Wn kn by e की power minus का j 2 pi is Wn kn. Yes. Similarly guys, if I talk about small xn, then it equal to 1 by n sigma of k equal to 0 to n minus 1 x of k, and if you want to write in form of total factor Wn minus ka k. Yeah. So if I talk about some important properties guys, so important properties, very important properties, xk at k equal to 0 will be always equal to sigma of n equal to 0 to n minus 1 into small xn. Important property, it means capital X0 is nothing but the summation of xn, whatever the xn value. This is the property number 1. The property number 2 again important, x of k, if k is replaced by capital N by 2. So it means if I will write here x of n by 2, it will give me sigma of n equal to 0 to n minus 1 and minus 1 की power n into x of n. So again very important properties. And जो सबसे important, जो सबसे ज़्यादा maximum time we have used to solve the gate problems, that is nothing but conjugate property. So xk equal to x conjugate of n minus ka k. So many times some DFT values are unknown, that we can find by using this, and where n is the point DFT, n is the point endpoint DFT given to you. All the three properties are very important. If I talk about the 4-point DFT, 4-point DFT, then the 4-point DFT is what guys? If you want to perform the DFT by using the matrix form, then you can find like this. You have to just multiply the values like 1, 1, 1, 1, here is minus 1, minus 1 again, minus 1, minus 1, it is plus 1, it is minus j, it is plus j, it is plus j, it is minus j, and you can multiply with the value of small x0, small x1, small x2, small x3. So when you will multiply, you can just do the multiplication, you will get the answer. You will get the answer. Is this clear, beta? Now I am just taking a, what is the drawback? What is the drawback and computation of DFT and FFT? What is the advantage of this? Is the DFT, this is the FFT. So complex multiplication, how many complex multiplication we have? So complex multiplication and complex addition. and complex addition. So complex multiplication we have in the DFT n square, and complex addition we have here n into n minus 1. Whereas in the FFT we have n by 2 log of 2n, and here it will have n into log 2n. So this is the biggest advantage of FFT, known as fast Fourier transform. FFT allow us to compute the DFT on digital computer with considerable saving in computation time. Computation time कम हो जाएगा. So here n square multiplication required, n into n minus 1, where n by 2 log 2n and n log 2n required. If I talk about DIT FFT algorithm, DIT FFT, so how it will work in the butterfly? Actually, if here the butterfly like this, guys, butterfly like this. So if here is A, here is B, so here it will be actually A plus B, W and K, and here it will be A minus ka B, W and K. Like that the DIT FFT works. Okay, प्यारे बच्चों, so देखो, in this session, today's session, we have not planned any formulas or any questions, PYQs and all. This is just session I have planned to revise the concept, important formulas, important properties, important short trick. Okay, प्यारे बच्चों, so bye bye. That's all from today's session. After 5 minutes, I will share the PDF of this part 1, part 2, part 3. In 3 terms, I will share in the Telegram group of IMS Gate Academy. So IMS Gate Academy group, if you have not joined, you should join it. The link of Telegram is given in the description. Okay, प्यारे बच्चों, चलो. Narupal, is this clear beta? Bye bye beta Narup, Gopal. Good night, take care. That's all from today's session, प्यारे बच्चों. And one more student, जो playlist, the last topic, if you are looking for, just search the Signals and System Mega Marathon, 10-hour marathon. In that you will get the last chapter, DTFS. Okay? Thank you very much, sir. Helpful session. Naru Gopal. You are most welcome, beta. Most welcome, and all the very best for your exam. Okay, beta. Chaliye, thank you.